Russia said it was impossible. Ukraine did it anyway. It rewrote the rules of modern warfare. Even military experts are still trying to explain how it happened. We are counting down the top 10 most unbelievable Ukrainian strikes on Russia in 2025, starting with number 10, and building up to the single most jaw-dropping operation of the war so far. Let's start with number 10. The Ukrainian operators waited for a Russian ship worth over $675 million to dock in Black Sea. But what happened next shocked everyone. At 0023 local time on October 6, 2025, 12 Ukrainian operators sit in 3 hidden bunkers outside Odessa, watching their screens light up. In exactly 47 seconds, they will launch the most complex drone attack in naval warfare history. Their target, the Russian landing ship Olenogorski Gornyak, a $675 million warship currently docked at Novorossiysk port, completely unaware it has less than 4 hours to live. But first, they need to blind the Russians. At 0024 hours, 48 decoy drones launch simultaneously from positions spread across 15 kilometers of Ukrainian coastline. These aren't military drones. They're modified commercial quadcopters. Each one costs about $800. Total value, $38,400. The Russians are about to waste $50 million worth of missiles shooting them down. Before we begin, make sure to hit like and subscribe. It really helps the channel grow. The moment those 48 motors spin up, every Russian electromagnetic sensor within 20 kilometers goes crazy. The sudden spike in electrical activity lights up their screens like someone just turned on 48 flashlights in a dark room. At the Sevastopol Integrated Air Defense Command, Lieutenant General Volkov sees the incoming swarm and makes the exact decision Ukraine wants him to make. Engage all contacts immediately. This is where the trap springs. Every S-400 missile costs $1.2 million. Every Panzer interceptor costs $140,000. Every Tor missile costs $250,000. The Russians are about to trade Ferraris for bicycles, and they think they're winning. At 0026 hours, the first S-400 battery opens fire from position Alpha 7 near Yevpatoria. The massive 48 N6E2 missile accelerates to Mach 6 in 12 seconds, racing toward a plastic drone that costs less than an iPhone. The missile's 180-kilogram warhead detonates, turning the $800 drone into confetti. The Russian operators cheer. They just played themselves. Here's what the Russians don't understand yet. Every time they fire, their radar has to paint the target with electromagnetic energy. That energy has a specific frequency, a specific pattern, a specific location. Ukrainian SIGINT, Signals Intelligence teams, are recording everything. It's like the Russians are drawing a map of their own defenses with neon markers. By 0029 hours, the Russians have launched 31 interceptor missiles at the decoy swarm. Success rate, 87%. They've destroyed 42 drones worth $33,600 total. Cost to Russia, $14.7 million in missiles alone. But the real cost is much higher. They've just revealed the exact positions of every air defense system protecting Crimea. While this expensive fireworks show lights up the night sky, the real attack force is already moving. These aren't toys from Amazon. These are purpose-built killing machines with names that sound like mythology. Peklo heavy strike drones, UJ-26 Bober extended range platforms, and AQ-400 scythe sea skimmers. At 0018 hours, 6 minutes before the decoy launch, the first wave of Bober drones had already taken off from hidden launch sites near Berezivka. Why so early? Because Bobers are marathon runners, not sprinters. Maximum speed, 135 kilometers per hour. Time to target, 2 hours 47 minutes. Each one carries a 50-kilogram penetrator warhead designed to punch through reinforced concrete. At 0031 hours, with the Russians still shooting at decoys, the Peklo missiles launch. These are the opposite of Bobers, pure speed demons. 0 to 700 kilometers per hour in 23 seconds. Time to target, 41 minutes. Each Peklo carries a 120-kilogram warhead with an imaging seeker that can recognize specific targets from memorized satellite photos. At 0033 hours, the AQ-400 scythes join the party. These are the ninjas of the group. They fly just 30 meters above the ocean waves, so low that Earth's curvature hides them from radar until they're basically on top of you. Speed, 290 kilometers per hour. Warhead, 30 kilograms of shaped charge explosive. The timing is everything. Different speeds, different launch times, but all calculated to arrive at their targets within the same 90-second window. It's like ordering pizza, Chinese food, and burgers from different restaurants and having them all arrive at exactly 01:45 hours. At 00:35 hours, Russian radar operator Sergeant Dmitry Volkov at Station November 3 notices something weird on his scope. The 96L6E radar, part of the S-400 system, shows targets appearing and disappearing. 1 second there's nothing, next second there's a contact, then nothing again. This is because the scythes are literally surfing the radar horizon. When they ride up on a wave, they appear. When they dip into a trough, they vanish. The radar computer tries to track them, but keeps losing lock. It's like trying to watch a dolphin from shore. You see it jump, then it's gone. Then it jumps again somewhere else. At 30 meters altitude, the radar horizon for a system positioned at sea level is exactly 19.6 kilometers. The scythes know this. Their flight computers keep them at precisely 2733 meters. Low enough to hide, high enough to avoid actually hitting the waves. 1 meter too high, and they're visible from 50 kilometers away. 1 meter too low, and they're submarine. At 00:42 hours, the Russians activate their trump card, the Kuka-4 electronic warfare system. This $8 million vehicle starts pumping out 10 kilowatts of jamming power across every GPS frequency. It's like screaming so loud that nobody within 30 kilometers can hear anything else, but the Ukrainian drones don't care. When GPS dies at 00:43 hours and 12 seconds, their flight computers instantly switch to INS, Inertial Navigation System. Inside each drone, a ring laser gyroscope spins light around a fiber optic loop 100,000 times per second. Any rotation of the drone changes the time it takes light to complete the loop. By measuring these tiny changes, the drone knows exactly how it's moving without any external signal. The INS accuracy, 0.1% drift per hour. Over a 2-hour flight, that's 200 meters of error. But the drones don't need to be perfect. They just need to get close enough for their terminal guidance to take over. At 01:45 hours, the first strike package reaches inland Crimea. Target, Jankoy Railway Junction, the main supply artery feeding Russian forces in southern Ukraine. 3 AQ-400 scythes approach at 290 kilometers per hour, 30 meters altitude, following the exact path of the E-105 highway to mask their approach. Russian BTR-82A at checkpoint. 17 spots them at 1.2 kilometers. The gunner has exactly 14.8 seconds to engage before they pass. He opens fire with the PKTM machine gun, 800 rounds per minute of 7.62 millimeter bullets. But hitting a target moving 80 meters per second at that angle requires leading by 18 meters. By the time he calculates the lead, they're gone. The first scythe slams into the rail signal box at 01:46:07. The 30-kilogram shaped charge punches through 400 millimeters of reinforced concrete like it's cardboard. The signal system dies instantly. Every train within 50 kilometers automatically stops, safety protocol. The second and third scythes hit the switching points at 01:46:09 and 01:46:11. These aren't random strikes. Ukrainian intelligence studied this junction for months. They know destroying these specific switches will take 72 hours minimum to repair. For 3 days, nothing moves through this junction. At 01:47 hours, 4 Bobers and 1 Peklo converge on Ammunition Storage Site 7 near Armyansk. This facility holds 1,200 tons of artillery shells for the 18th Combined Arms Army. The Russians think it's safe. It's 45 kilometers from the front line, surrounded by S-300 batteries, protected by 2 Panzer systems. The first Bober impacts the perimeter fence at 01:47:33. Its 50-kilogram warhead seems wasted on a fence, but this is intentional. The explosion creates a gap, and more importantly, a smoke cloud. For 12 seconds, thermal imaging can't see through the carbon particles in the air. During those 12 seconds, 3 more Bobers and the Peklo slip through undetected. The Peklo's imaging seeker has memorized what Russian 152mm shell crates look like from satellite photos. It finds the biggest concentration and dives. At 01:47:51, the Peklo's 120-kilogram warhead detonates in the middle of Storage Building 3. The initial explosion is just the trigger. 1 millisecond later, 400 tons of artillery shells start chain reacting. 2 milliseconds later, the building doesn't exist anymore. 3 milliseconds later, the shockwave hits Storage Building 4. The explosion registers 2.1 on the Richter scale. Windows break 8 kilometers away. The mushroom cloud climbs to 2,100 meters. Estimated damage, $87 million in ammunition. 4 months of shell production, gone in 3 milliseconds. While Crimea burns, 10 drones are screaming toward Feodosia Port's fuel terminal. This is the big prize. 14 storage tanks holding 120,000 tons of diesel and aviation fuel. Without this fuel, every Russian vehicle in southern Ukraine stops moving. At 01, 51 hours. Panzer system at grid reference 44.5521, 35.3792. Gets the first lock. The operator sees 10 targets approaching at different altitudes, different speeds, different angles. His 57 E6 missiles can engage 2 targets simultaneously. He has 1.3 seconds to decide which 2. He chooses wrong. The 2 high-altitude drones he engages are the slowest ones. Easy kills but lowest priority. While his missiles chase them, 8 others slip past. By the time he can re-engage, they're inside his minimum range. The Panzer's guns can't depress below -5 degrees. At 300 meters distance and 30 meters altitude, the drones are geometrically impossible to hit. At 01, 52, 17, the first drone hits Tank 7, a massive cylinder holding 15,000 tons of diesel. The explosion punches a 2-meter hole at exactly 4.5 meters height, calculated to be above the fuel line but below the vapor space. This prevents immediate ignition but ensures maximum fuel spillage. At 01, 52, 19, the second drone hits the same tank, same height, opposite side. Now fuel is pouring out from 2 holes at 300 liters per second. At 01, 52, 22, the third drone carries white phosphorus incendiary. It doesn't aim for the tank. It aims for the growing pool of fuel spreading across the containment area. Tank 7 explodes at 01, 52, 31, launching its 500-ton roof 200 meters into the air. This pattern repeats across the tank farm. Precise hits, calculated damage, inevitable ignition. By 01, 54 hours, 7 tanks are burning. The heat is so intense that Tank 11, completely undamaged, starts boiling anyway. Its safety valves release, adding more fuel vapor to the inferno. At 01, 47 hours, while everyone's watching the fires, 6 Ukrainian sea drones slip out of hidden bays near Odessa. These aren't regular boats with remote controls. These are purpose-built naval killers. The Sea Baby Mark V, 5.5 meters long, 850 kilograms total weight, 200 kilogram warhead, maximum speed 42 knots, 78 kilometers per hour. Cost to build, $46,000. Extish. The Magura A5, 7 meters long, 1,100 kilograms weight, 320 kilogram warhead, maximum speed 48 knots. Cost $67,000. Their target, the Olenogorsky Gornyak, a Ropucha-class landing ship built in 1976, currently docked at Novorossiysk, value $675 million. It's the last operational landing ship in the Black Sea Fleet capable of carrying main battle tanks. The sea drones don't take a direct route. That would be suicide. Instead, they follow commercial shipping lanes, hiding in the radar shadows of cargo vessels. When the bulk carrier Volga Dream passes 2 kilometers from Novorossiysk at 02, 11 hours, 3 Sea Babies tuck behind it, invisible to Russian coastal radar. At 02, 23 hours, Russian coastal defense picks up intermittent contacts on radar, but the returns are weird. They appear for 2 seconds, disappear for 8, appear again somewhere else. The operator thinks it's wave clutter. It's actually the drones surfing waves. When they ride up a wave, they're visible. When they slide down the back, they disappear below the radar horizon. The drones are also smart about their electromagnetic signature. They emit no radio signals, except for a 100 millisecond burst every 30 seconds, just enough for operators to confirm they're on course. The rest of the time, they're electromagnetically invisible. At 02, 34 hours, the lead Magura 5 is 800 meters from the Olenogorsky Gornyak. The operator, sitting in a bunker 180 kilometers away, takes manual control. Through a satellite data link, he can see the live camera feed. Grainy, green-tinted night vision, but clear enough to see individual sailors smoking on deck. At 02, 35, 44, the operator picks his impact point. 2 meters below the waterline, 38 meters from the bow, directly under the engine room. This isn't random. Ukrainian intelligence knows from stolen blueprints that this spot has the thinnest armor, just 8 millimeters of steel. At 02, 36:17. The Magura hits the Olenogorski Gornyak at 48 knots. The 320-kilogram warhead detonates on impact. The explosion creates an instantaneous cavity in the water, 8 meters wide. Water pressure at 2 meters depth is 1.2 atmospheres. When the cavity collapses 0.3 seconds later, it generates a secondary pressure wave of 15,000 psi. The combined effect tears a hole 6 meters wide in the hull. Seawater rushes in at 14,000 liters per second. The engine room floods in 47 seconds. Without power, pumps stop. Emergency lighting fails. The ship immediately lists 7 degrees to port. At 02:36:51, the second Sea Baby hits 15 meters behind the first impact. This warhead is different. Thermite incendiary designed to burn through bulkheads. It punches through the hull and ignites inside the fuel bunker. Diesel fuel doesn't explode like in movies. It burns. Slowly, intensely, impossible to extinguish with water. At 02:37:23, the third drone aims for the propeller shaft. When it detonates, it doesn't just damage the propeller, it bends the shaft 11 degrees. Even if the ship somehow survives, it will never move under its own power again. By 02:40 hours, the Olenogorski Gornyak is listing 18 degrees. The captain orders abandon ship at 02:41. But there's a problem. The lifeboats on the port side are underwater. The ones on the starboard side can't launch because of the list angle. Sailors jump directly into the harbor. In October, the Black Sea temperature is 14 degrees Celsius. Without survival suits, they have maybe 30 minutes before hypothermia sets in. At 02:44 hours, the ship's list reaches 35 degrees. Internal bulkheads, designed to withstand 15 degrees of list, start failing. Each failure floods another compartment, increasing the list, causing more failures. Naval architects call this progressive flooding. Once it starts, it's unstoppable. At 02:47:33, 4 hours and 24 minutes after the first drone launched, the Olenogorski Gornyak capsizes completely. The ship that survived 49 years of service, that transported thousands of tanks and vehicles, destroyed by 3 robot boats built in a garage. The aftermath. At 08:00 hours, Russian Ministry of Defense releases a statement. Ukrainian terrorist attack largely repelled. Minor damage to port infrastructure. No significant losses. At 08:15 hours, commercial satellites release images showing the Olenogorski Gornyak upside down in Novorossiysk harbor. 7 fuel tanks still burning at Feodosia. Ammunition depot crater visible from space. Railroad tracks twisted like spaghetti. The images go viral. Russian Navy sleepers, with Fish's trends worldwide. The minor damage becomes a global meme. But the real damage isn't the money or the embarrassment. It's the fear. Every Russian ship captain now knows that any night, robot boats could come for them. Every ammunition depot commander knows drones can appear from nowhere. Every train engineer checks the sky constantly. This attack proves 3 game-changing facts. First, naval superiority means nothing against swarm tactics. The Olenogorski Gornyak had defensive weapons worth $50 million, useless against a drone moving 3 meters above water at 48 knots in darkness. Second, electronic warfare isn't a magic shield. The Russians jammed GPS perfectly. The drones didn't care. INS, fiber optics, and human operators beat billion-dollar jamming systems. Third, cost asymmetry is the new king of warfare. Why build a $2 billion destroyer when $2 million in drones can sink it? In the Ukrainian bunkers, operators watched their screens as months of planning executed perfectly. These weren't soldiers in the traditional sense. Some were gamers, some were engineers, some were university students who grew up flying racing drones. At number 9, we have a perfectly planned strike on the Dnipro Bridge. Let's watch. 2:15 a.m. The Dnipro River Bridge, eastern Ukraine. The convoy stretched for 5 miles, over 500 vehicles crawling bumper to bumper across a steel bridge that wasn't built to handle this kind of traffic. Ammunition trucks, fuel tankers, command vehicles packed with communications equipment. All of it heading south to resupply 2,000 Russian troops holding positions near Melitopol and Tokmak. The Russian convoy commanders weren't worried. They had Panzer S-1 air defense systems positioned along the route. Their 30mm autocannons and 57 E-6 missiles ready to swat anything out of the sky. Overhead, a Nebo M radar swept the airspace every 3 seconds. capable of tracking objects the size of a baseball from 200 yards away. The Russians believed they were safe, covered from every angle. They had no idea that directly beneath their wheels, clamped to the steel beams of the bridge they were crossing, 12 Ukrainian FPV drones had been waiting for 72 hours. And they were about to wake up. 72 hours earlier, Ukrainian special operations teams had infiltrated the area around the Dnipro River Bridge under cover of darkness. Their mission wasn't to blow the bridge immediately, it was to set a trap so perfect that when it sprung, it would cripple an entire Russian division. The drones they carried weren't expensive military hardware. Each one cost about $600, basically consumer-grade quadcopters modified with military-grade warheads. Specifically, PG-7 VL-shaped charges, the same warheads used in RPD-7 rocket launchers. Each warhead could pierce 12 inches of reinforced concrete or punch through most armored vehicles. But here's what made these drones special. They didn't rely on GPS. Ukrainian engineers had programmed them with onboard LiDAR, basically laser-based mapping that lets the drone see its surroundings and navigate using pre-loaded 3D maps of the bridge structure. No GPS signals to jam, no radio communications to intercept, no human pilot required once activated. The operators carefully attached each drone to the underside of the bridge using magnetic clamps. Then they activated sleep mode. The drones would sit there, completely inert, drawing minimal power from their batteries, waiting for a single encrypted wake-up command. All they needed now was the right target, and Ukrainian intelligence had been tracking Russian logistics patterns for weeks. They knew a major resupply convoy was coming. They knew the route. They knew the timing. Now it was just a matter of patience. 2:13 a.m. The convoy slowed to a crawl. A bottleneck had formed on the bridge, too many vehicles trying to cross too quickly. And here's where Russian logistics bit them hard. Cheap truck tires. You see, due to Western sanctions and corruption in military procurement, many Russian military trucks were running on substandard tires. Some were civilian models never designed for heavy military loads, and those tires were failing. A blown tire here, an overheating engine there. Small problems that in normal circumstances would be minor annoyances. But on a narrow bridge with 500 vehicles packed together, small problems become catastrophic bottlenecks. The convoy ground to a near standstill. Vehicles bunched up. Fuel tankers sat next to ammunition trucks. Command vehicles were trapped in the middle of the pack with no room to maneuver. It was the perfect kill zone. In a hidden Ukrainian command post several kilometers away, an intelligence officer watched the real-time feed from a reconnaissance drone circling high above. He could see the entire convoy stretched across the bridge, the thermal signatures of fuel tankers glowing hot, the distinctive shapes of ammunition carriers, the electronic emissions from command vehicles. He picked up his encrypted communicator and sent a single message. Target in position. Execute. 2:15 a.m. Each FPV drone received the encrypted wake command simultaneously. Internal computers booted up, motors initialized, onboard LiDAR systems activated, mapping the bridge structure and confirming position. The magnetic clamps released. 12 drones dropped 3 feet before their brushless motors spun up with a low-pitched hum that was completely drowned out by the noise of 500 idling truck engines overhead. The drones didn't immediately attack. Their programming was more sophisticated than that. They flew in tight formation, hugging the concrete support columns to avoid visual and radar detection. Their onboard AI systems armed the PG-7 VL warheads, setting them to detonate 1.1 seconds after impact, just enough delay to penetrate the target before exploding. The drones divided into 3 groups, 6 targeted ammunition trucks, 4 locked onto fuel tankers, the final 2 aligned with the convoy's lead command vehicles. And then something unexpected happened. A Russian lieutenant sitting in a Panzer S-1 command vehicle noticed slight electronic interference on his displays. Nothing dramatic, just a flicker, a minor anomaly in the radar returns. Standard procedure would be to ignore it, chalk it up to atmospheric conditions or interference from all the vehicles. But this lieutenant had survived 2 years of war by being paranoid. He switched the Panzer system from passive to active radar mode, flooding the area with radio waves to get a clearer picture. And that's when the system detected something. A small heat signature below the bridge, moving. The automated targeting system locked on a 57 E6 missile launched from its tube with a flash of flame and a roar that echoed across the river. The missile streaked downward, accelerating to over 1,800 miles per hour in seconds. It struck a Ukrainian decoy drone that had activated exactly for this purpose, to draw fire and reveal Russian defensive positions. The explosion lit up the night. A fireball rose 30 feet into the air. Debris scattered across the riverbank, and on the bridge, absolute chaos erupted. Drivers slammed on brakes, engines stalled, trucks jackknifed, horns blared. A 5-mile line of orderly convoy collapsed into confusion. Radio chatter exploded, drivers shouting coordinates, officers demanding status reports, air defense operators scanning frantically for more targets. Red warning lights flashed in Panzer dashboards. A Tor M2 mobile air defense system tried to acquire target locks, but the steel structure of the bridge created so much radar clutter that the system was seeing false returns everywhere. And here's what the Russians didn't realize. The explosion did something far more valuable than destroying one cheap decoy drone. It confirmed to the Ukrainian operators that Russian air defenses were active, alert, and exactly where intelligence had predicted. Trap was working perfectly. Instead of pressing the attack, the remaining 11 drones executed evasive protocol. Their onboard AI recognized the change in battlefield status, air defenses active, convoy alerted, and adapted. They slipped back under the bridge supports, using the steel structure to mask their signatures. One drone, Drone 3, activated its onboard X-band jammer. It's a small electronic warfare device that floods specific radar frequencies with noise. The Panzer radar screens went from fuzzy to complete white static. The operators couldn't see anything. 40 miles north, a Russian Buryev, a 50 radar aircraft, essentially a flying command center with massive radar arrays, was circling at 30,000 feet. Its Shmel-M radar system picked up unusual heat patterns over the bridge, small moving objects at low altitude. The A-50 transmitted a top-down targeting feed directly to ground units. Suddenly, the Panzer's radar cleared. A targeting reticle locked back onto Drone 9. A Tor M2 system received the same data and fired a 9M338 missile. This missile is specifically designed to hit small, fast-moving targets. It raced toward the drone at 1,850 miles per hour, over twice the speed of sound. Drone 9's AI immediately deployed its countermeasure. From its underside, a 100-foot-long fiber optic cable unspooled. At the end, an AN-AL-50 decoy activated, a small device that sends back amplified radar reflections, making the system think it's tracking something much larger. The Tor missile veered sharply, chasing the false signature. 3 seconds later, it detonated in mid-air, destroying the decoy. The real drone survived. Every Russian radar operator in a 50-mile radius was looking at the bridge. They knew something was happening, they just didn't know what. And that's when the Ukrainian command operator sent the final signal. Execute. 11 drones powered back on, but this time they weren't hiding. They launched straight up at full throttle, their motors screaming at 18,000 revolutions per minute, covering the final 200 yards in under 6 seconds. The kill phase had begun. Drone 1 reached the underside of the bridge deck, directly below an ammunition truck carrying 120mm mortar shells and 122mm artillery rounds. Its PG-7VL warhead struck reinforced concrete and detonated after the programmed 1.1-second delay. The shaped charge worked exactly as designed. It focused explosive energy into a narrow jet capable of piercing 12 inches of reinforced concrete. The explosion punched through the bridge deck and into the ammunition truck above. The secondary explosion was catastrophic. Mortar shells and artillery rounds detonated in a chain reaction. The fireball reached 70 feet high. But here's where Ukrainian planning showed its brilliance. The explosion echoed downward, reflecting off the river surface 30 feet below. Water is incompressible, so the blast wave bounced back up, creating a compression effect that multiplied the force against the bridge's support structures. The concrete support column, designed to bear vertical weight from traffic, was suddenly hit by massive lateral force. Steel rebar inside snapped instantly. The bridge shook, and 7 more drones struck within the next 1.3 seconds. Drone 2 hit beneath a second ammunition cluster. Another massive secondary explosion. Drone 3 detonated under a tanker carrying JP-8 jet fuel. The tank ruptured, fuel ignited, flames rolled across broken asphalt. Drones 4 and 5 hit simultaneously beneath 2 more fuel vehicles. Each explosion fed into the next, creating an expanding inferno. Drone 6 targeted a mobile command post, a specialized vehicle housing communications equipment and tactical computers. The shaped charge punched through the vehicle's floor and detonated inside. Every officer in that vehicle died instantly. Command and control for the entire convoy gone. The final 4 drones struck support columns in synchronized succession. Each warhead added more lateral force to structures already weakened by the initial blasts. At 2:17 a.m., just 2 minutes after the first drone activated, the southern half of the bridge gave way. 40 Russian vehicles dropped into the kill zone. The first to fall was a Ural truck carrying 82mm mortar shells. It landed nose first on top of the initial blast crater. The impact triggered every shell in the cargo bed simultaneously. The detonation was massive. A sympathetic explosion that ignited 2 adjacent trucks, each carrying a mix of 122mm and 152mm artillery rounds stacked in wooden crates. Explosion punched through the bridge deck and into the ammunition truck above. Air defense systems can track the approach. Electronic warfare can jam signals. The element of surprise is limited, but Ukraine's approach was completely different. They pre-positioned the drones days in advance. No flight time means no approach to detect. No active signals means nothing to jam. The drones simply waited, invisible and inert, until the perfect target presented itself. The Russians were scanning the skies for threats. They never thought to check under their wheels. It's brilliant in its simplicity, and it fundamentally changes how we think about drone warfare. The threat isn't something approaching from the distance. The threat is already there, sleeping beneath your feet, waiting for the perfect moment. The technology, simple but devastatingly effective. The drones themselves weren't cutting-edge military technology. They were modified commercial quadcopters, the kind of platform you could build from components available online. The PG-7 warheads are old Soviet-era technology from the 1970s, designed for RPG-7 launchers. Reliable, effective, and critically, cheap and widely available. The LiDAR navigation is basically the same technology used in robot vacuum cleaners. Laser-based mapping that 3D picture of the environment. None of this technology is exotic. None of it requires advanced manufacturing or rare materials. But combined cleverly, with good intelligence and perfect timing, it becomes devastatingly effective. This is asymmetric warfare at its finest. Using simple, inexpensive tools to destroy expensive, sophisticated targets. Not by matching the enemy's capabilities, but by finding weaknesses in their doctrine and exploiting them ruthlessly. The Dnipro bridge strike represents something larger than a single successful operation. It's a glimpse into the future of warfare. Traditional military thinking focuses on firepower, armor, and maneuver. Tanks, aircraft, artillery, big, expensive systems operated by highly trained personnel. But modern warfare is increasingly about information, timing, and precision. Small drones, AI algorithms, pre-positioned assets, asymmetric attacks that achieve strategic effects with minimal resources. The most dangerous weapon isn't the one with the loudest blast. It's the one you never see coming. Not the missile, but the algorithm. Not the tank, but the code. Not the firepower, but the patience to wait 72 hours for the perfect moment. Russia prepared for a conventional war. They deployed traditional air defenses. They followed standard convoy procedures. They assumed the quantity, 500 vehicles, multiple air defense systems, overhead radar coverage would provide security. They were fighting yesterday's war with yesterday's tactics. Ukraine is fighting tomorrow's war and winning. Lost in the technical discussion are the Ukrainian special operations personnel who set this trap. Think about what that mission required. Infiltrating behind enemy lines to plant drones under a bridge, waiting 72 hours, 3 full days for the target to arrive, maintaining operational security, trusting that the intelligence about convoy timing was accurate, betting everything on a plan that required perfect execution. One mistake, one Russian patrol discovering the drones, one premature activation, one technical failure, and the entire operation collapses. But they executed flawlessly. The drones were positioned perfectly. The timing was exact. The targeting was precise. Every element of the plan worked. That's not luck. That's professionalism, training, and nerve. This strike sent a clear message that Russian military planners can't ignore. Your logistics are vulnerable. Your convoys are targets. Your bridges are death traps. Every supply run is a risk. Every choke point is a potential ambush. Every routine mission could end in catastrophic failure. Russia can't defend everything, can't check every bridge for hidden threats, can't guarantee safe passage for critical supplies. At number 8 comes a hit directly into the heart of a Russian mine factory. Let's watch. October 22nd, 2025, 2:03 a.m. Saransk, Mordovia, Russia. 48 Ukrainian drones were closing in on their target. This was the Saransk mechanical plant, the factory building the very mines that had turned eastern Ukraine into a death trap. The mines that killed Ukrainian soldiers trying to advance. And inside that factory, right now, 150,000 fully assembled mines sat in warehouses, ready to ship to the front lines. The drones pushed forward through the darkness. Then, exactly as Ukrainian intelligence knew it would, Russia's Krasuka-4 electronic warfare system roared to life. 500 watts of jamming energy flooded every GPS frequency. For any normal drone relying on satellite navigation, this would be the end. The drones would lose their guidance, drift off course, maybe crash. But these weren't normal drones. Ukrainian engineers had installed custom software that did something clever. The moment GPS signals disappeared, the drones didn't panic. They switched to a backup system that used onboard cameras to compare what they were seeing below against pre-loaded satellite maps. Think of it like your phone's Maps app, but instead of GPS telling you where you are, the drone figures it out by recognizing roads. All 48 drones kept flying, completely unbothered by Russia's electronic warfare. They hugged the terrain at just 40 feet altitude, staying below long-range radar coverage. And they were about to show Russia that expensive defensive systems have a fatal weakness: limited ammunition. Of those 48 drones, only 4 carried the real warheads meant to destroy the factory. The other 44 were decoys, cheaper drones designed to look threatening but carrying minimal explosives. Their job wasn't to destroy anything. Their job was to make Russia waste ammunition. Before we begin, make sure to hit like and subscribe. It really helps the channel grow. At 2:06 a.m., the decoy drones suddenly climbed from 40 feet to 1,000 feet altitude. They lit up on Russian radar screens like a Christmas tree. The Panzer S-1 air defense system operator stared at his screen. 44 contacts. Incoming fast. This was exactly the kind of mass drone attack Russia had been preparing for. But here's the problem. The Panzer system can track dozens of targets, but it can only engage 4 at a time, and it carries just 12 ready-to-fire missiles before it needs to reload. The operator did what he was trained to do. He started shooting. 5 seconds later, 12 missiles screamed into the sky. each accelerating to Mach 3.5, over 2,600 miles per hour. 12 explosions, a perfect 100% kill rate. The operator probably felt pretty good about that. Ukraine wasn't attacking the Panzer's radar or its missiles. They were attacking its limited ammunition capacity. They were forcing Russia to spend expensive missiles shooting down cheap decoys. After a frantic reload, the Panzer fired again at 2:06:27 a.m. Another 12 missiles, another 12 decoys destroyed. The Panzer had now fired 24 missiles and destroyed 24 targets. The problem? It had just used half its total ammunition to destroy about $720,000 worth of plywood frames and basic electronics. And then the system's screen showed the message Ukrainian planners had been counting on. Ammunition depleted. Reload cycle initiated. A 60-second pause. 60 seconds where the Panzer couldn't shoot anything. During that minute, the remaining drones, including the 4 real attackers carrying actual warheads, closed the distance to just 5 miles. The Panzer was out of the fight, but you might be wondering, how did those 4 real drones stay hidden while the decoys were getting shot down? This is where the operation gets really clever. Ukrainian intelligence hadn't just been watching the Saransk factory, they'd been studying it for weeks, monitoring radio frequencies, learning call signs, tracking daily routines. And most importantly, they'd figured out that every night at 2 a.m., a supply truck arrived for the shift change. So Ukraine timed their drone attack to coincide with that truck's arrival. And here's the genius part. The 4 real attack drones flew directly behind and below that truck, using its radar and heat signature to hide their own. To Russian sensors, it just looked like the usual supply truck. Nothing unusual, nothing threatening. The truck approached the factory's main gate, completely unaware it was being used as a shield for 4 drones carrying enough explosives to level the facility. At 2:08 a.m., the swarm reached the factory's physical defenses. This wasn't just a fence. This was a sophisticated anti-drone system combining steel netting with electronic sensors. And on the night of October 22nd, thick fog rolled across Saransk. This wasn't luck. This was patience. The 20 remaining decoy drones charged at the factory perimeter from multiple directions. Russian guards opened fire with everything they had: machine guns, shoulder-fired missiles. Complete chaos. Every guard was looking up at the aerial swarm, convinced that was the main attack. The 4 real AQ-400 drones, still perfectly masked by the truck's signature, slipped through the gap. They were inside. At 2:10 a.m., Russian rapid response teams screamed onto the scene. 3 armored vehicles and a Zu-23-2 anti-aircraft cannon mounted on a truck. They were exactly 30 seconds too late. The gunner on the Zu-23-2 spun his turret, desperately looking for targets. His weapon was a Soviet-era anti-aircraft gun, designed in the 1960s to shoot down helicopters. It's effective, but it needs about 10 seconds to aim its heavy barrels, calculate where to shoot, and fire. The 4 Ukrainian drones were already inside the perimeter, their onboard AI systems using thermal imaging to lock onto the main target. The drones weren't flying straight, they were diving, accelerating, adjusting their path in real time, based on the warehouse's glowing heat signature. The gunner managed to track the 4th drone for a fraction of a second and fired. The explosive shells walked across the sky just behind the drone's tail. A near miss. The first Scythe drone slammed into the northwestern corner of Building 7, the final assembly and main storage hall. The drone's 25-pound warhead wasn't designed for a simple explosion. It was a surgical tool. Before the main explosive detonated inside the building, what happened next was catastrophic. The initial blast created a supersonic pressure wave, a physical wall of force moving at 300 pounds per square inch. Intense heat superheated the explosive material inside those mines, pushing them past their safety threshold. The result wasn't a slow chain reaction. It was near instantaneous sympathetic detonation. One mine exploded, setting off the next, which set off the next, all in under 2 seconds. The entire northern half of the warehouse erupted in a single massive blast. 3 seconds later, the second drone hit Building 4, the fuse and igniter assembly line. This wasn't about creating a big explosion. This was about destroying Russia's ability to produce more mines. Volatile chemical precursors ignited, turning the precision workshop into a chemical inferno. This production line would be offline for years. Then the third and fourth drones executed the most brutal step. They flew into the already burning southern section of Building 7. These weren't redundant strikes. They were designed to feed the fire. The impacts ripped open the structure, allowing a massive influx of oxygen that turned the fire into a self-sustaining firestorm, a convective engine of destruction that no fire department on Earth could approach. The factory wasn't just damaged, it was destroyed. Russian generals who were carpet-bombing the front lines with mines now have to ration them. They're forced to make hard choices about which sectors are valuable enough to defend with minefields. Ukrainian forces are already reporting reduced mining activity in certain sectors. Areas that would have been impassable last month are now potential breakthrough points. Russia's defensive advantage is eroding. This single attack created an impossible dilemma for Russian commanders. For 2 years, they'd prioritized protecting frontline forces with dense air defense coverage. The Saransk strike proved that doctrine was obsolete. The rear was now a battleground. Moscow was forced to choose: protect the troops or protect the factories that supply them. They chose the factories. An estimated 50 Panzer systems were pulled from frontline positions to guard critical infrastructure hundreds of miles from the fighting. In doing so, they created gaps in battlefield air defense. Formal invitations for Ukrainian strike aircraft and long-range missiles to start dismantling Russian command posts and artillery positions. Let's do the math. Ukraine spent approximately $1.4 million on 48 drones. In return, they inflicted $100 million in direct damages, crippled a critical supply line for 6 months, shattered Kremlin propaganda narratives, and forced Russia to weaken its own front line. That's a 7,000% return on investment, the kind of numbers that would make Wall Street hedge fund managers weep with envy. But wait, there was a second strike. While Saransk burned, another Ukrainian operation was underway 500 miles southeast in Makhachkala, the capital of Dagestan. 2 Lyutai long-range attack drones took a completely different approach. While the scythes flew low, the Lyutai flew high, cruising at 30,000 feet over the Caspian Sea using a flight path that kept them below the radar horizon for 90% of their journey, functionally invisible until the final minutes. Their target: a single 200-foot catalytic cracking tower at a refinery. The irreplaceable piece of equipment that turns crude oil into high-grade naval fuel for Russia's Black Sea fleet. Armed with specialized thermobaric warheads, the drones didn't just punch holes. They turned the entire tower into a massive fuel air bomb, creating an inferno that ruptured nearby storage tanks. These weren't 2 separate attacks. This was a single, brilliantly coordinated operation. A boxer's combination designed to hit 2 different parts of Russia's war machine simultaneously. Saransk was the body blow, attacking Russia's future capability to produce mines. Makhachkala was the knockout to the head, attacking Russia's present capability to fuel the fleet that's actively firing missiles. One strike suffocates the supply chain. The other suffocates the trigger puller. On the night of October the 22nd, 2025, Ukraine proved something terrifying for Russia. The myth of impenetrable air defenses is dead. The vaunted S-400 systems, the Panzer point defenses, the electronic warfare systems, all of them were either bypassed, depleted, or simply arrived too late. Ukraine didn't just pierce Russia's defensive bubble, they proved it doesn't exist. The strategic calculation has shifted. Russia can no longer assume its rear areas are safe. Every factory, every refinery, every critical piece of infrastructure is now a potential target, and defending everything is impossible. Ukraine is forcing Russia to make brutal choices: protect the front or protect the factories, maintain offensive operations or rebuild defensive coverage. Every decision comes with costs. October 22nd, 2025. 2:11 a.m. Saransk burns. 150,000 mines that would have killed Ukrainian soldiers advancing toward their own territory were consumed in fire before they ever reached the front. The factory that produced Russia's most effective defensive weapon is a smoking ruin. Russian commanders are scrambling to reroute supply chains, redeploy air defenses, and explain to soldiers why the impenetrable homeland just exploded. And Ukrainian operators are already planning the next strike, because this operation proved a fundamental truth. In modern warfare, the side that innovates faster wins. And right now, Ukraine is setting the pace. Russia built defenses designed to stop the last war. Ukraine is fighting the next one. The fires in Saransk will eventually burn out. But the strategic damage, the broken supply chains, the shattered morale, the forced redeployment of critical defenses, that will burn for months. One night, 48 drones, $100 million in damage, and a clear message to Moscow: nowhere is safe. Nothing is untouchable. At number 7, we have a Russian train driving with $1 million worth of secret cargo, but Ukrainian drones were already waiting for it. Let's watch. At 13:47 hours in occupied Zaporizhzhia, 12 Ukrainian drones push through the low morning haze, flying toward a Russian ammunition train at just under 100 kilometers per hour. In a concrete bunker several kilometers away, their operators watch grainy video feeds instead of the sky. What they do not see is that Russian artillery has already begun to bracket their position. The first 152mm shell lands roughly 800 meters away, close enough to sprinkle dust from the ceiling and rattle loose stones from the tunnel walls. The Russians pick them up the instant. 48 brushless motors spun up at the same time. That burst of electromagnetic noise rose from the tree line like a flare on every spectrum analyzer within 10 kilometers. To an artillery battery watching the electronic environment, it looked like someone had turned on stadium lights in the middle of a blackout. Inside the bunker, the Ukrainians understand what that means. They can cut power and live, abandoning the mission, or keep the drones in the air while shells walk closer. To reach the train, they need around 12 minutes. To pinpoint the launch site, the Russian guns need perhaps 3. They keep the drones moving. Far ahead, a Russian armored personnel carrier rolls along a dirt road parallel to the tracks. A gunner standing half exposed behind the turret hatch notices a dark cluster against the sky. 12 dots, low and fast. He swings his machine gun up and opens fire. Tracer rounds climbing in bright arcs. The swarm fractures on command. 4 drones climb. 4 drop to treetop height. 4 continue straight through the middle. Rounds crack through the air where they had been a heartbeat early. But there is something the Russians cannot see from below. Trailing behind each of the drones is a line of glass thinner than a strand of human hair. A fiber optic tether spooling silently from a reel. While Russian electronic warfare vehicles flood the air with noise across every common frequency, those filaments carry control signals as rapid pulses of light. Jamming works on radio waves. The fiber simply ignores it. The very expensive electronic warfare truck, parked near a junction, bristling with antennas and emitters, is reduced to the usefulness of an oversized diesel generator while the drones hum overhead, untouched by the storm of interference. The Russian artillery, however, is a different problem. The second shell lands 600 meters away, the blast rolling through the bunker like a muted thunderclap. The Ukrainians are not surprised. They planned for this. Their control teams are divided across 3 bunkers spaced roughly 500 meters apart, connected by narrow communication tunnels. That number was not random. A 152mm shell can produce a lethal fragment radius of around 300 meters. At 500 meters of separation, a direct hit on one bunker might shred it completely, yet leave the others untouched and fully functional. The Russians could be fortunate and smash one shelter. With extraordinary luck, they might catch 2, but they can never destroy all 3 at once with map fire. At least 8 drones will remain under competent control, no matter how accurate the barrage becomes. That guarantee is the backbone of the plan. The third shell lands closer still, roughly 450 meters away, and this one does more than shake dust from the walls. Shrapnel scythes through the air above the bunkers and across the valley, tiny shards moving at several times the speed of sound, indifferent to distance or intention. 3 fragments find their targets, slicing through 3 of the near-invisible tether. The glass filaments are only a few millimeters thick and part instantly. Drones 2, 5, and 8 lose their lifelines. Each of the severed aircraft shifts automatically to backup radio control and internal battery power, logic boards following contingency programming without hesitation. It keeps them flying, but it also exposes them to the full weight of Russian jamming. The other 9 drones, still linked through their fibers, continue to receive guidance as pulses of light racing through curled glass at a significant fraction of light speed. In Bunker 1, the senior operator issues the order they rehearsed: maintain control of all surviving drones while shifting station. Equipment is unplugged in a practice sequence, consoles folded, cables coiled. As the team withdraws into a low connecting tunnel, the next artillery shell slams into the empty bunker behind them, a direct hit that would have shredded human bodies. Chunks of reinforced concrete bounce off steel ribbing above the passage, while the team runs toward their alternate position, several hundred meters away. When they plug back in, their drones are still flying, still closing the distance to the train. The difference between radio and Viber is now painfully clear to the Russians as well. Inside the electronic warfare vehicle, an operator watches his wideband display as the system lights up. The incoming drones are detected at around 7 kilometers. He instructs the system to transmit across a broad band from around 100 megahertz through several gigahertz. Kilowatts of power pour into the sky in a controlled roar, designed to drown out everything from civilian drone link frequencies to satellite navigation signals. On his screen, 3 of the tracks wobble, then vanish into noise as their control links die. 9 others remain, disturbingly crisp. Their signal paths are not in the air at all. They travel through glass that runs all the way back to Ukrainian bunkers buried under meters of earth. The operator checks his equipment, then pushes more power into the air, saturating even more spectrum. He is trying to shout down a flashlight beam by yelling louder. The physics are indifferent to his effort. The 3 drones on radio backup are gone, their pilots staring at frozen frames and static. They will fly straight until batteries die, or they meet a tree, harmless now. The side effect of all that jamming begins to surface. The armored vehicle, at a checkpoint near the line, can see the swarm on thermal imaging and attempts to warn a nearby air defense unit. The crew hears only static, their encrypted radios live in the same spectrum, being hammered into uselessness by their own specialists. Russian forces have pulled a thick electromagnetic curtain across the battlefield and cut off their own vision beyond it. The 9 tethered drones do not care. They slide under that curtain like fish beneath a frozen river, following waypoints set by hands that never left the shelter. Out along the rails, the train engineer has been briefed about the rising threat from drones. His response is simple. He pushes the throttle levers forward until they meet their stops. The heavy consist groans as thousands of tons of steel, fuel, ammunition, and classified cargo begin to accelerate along worn track. Speed creeps upward from the low 40s to the high 40s and beyond. Inching toward the maximum the aging rails can safely handle. Each increase seems small from the cabin, but it has a brutal effect on the men guiding the drones. Every extra kilometer per hour, the train gains moves the planned intercept point several meters farther down the line. The operators must continuously adjust their courses, burning precious battery reserves as they fight both headwinds and moving coordinates. Back near the checkpoint, the crew of the armored carrier gets their own short window. The swarm is crossing their field of fire at an oblique angle, just inside the envelope, where their main gun can reach. The gunner tries to solve a geometry problem in his head. Small targets, fast lateral speed, very little time. He knows he must fire not at where the drones are, but where they will be after bullet flight time. At their current speed, that means leading them by several body lengths, pushing rounds into empty air and waiting for the drones to intersect the stream. In theory, it is routine. On a range, targets move predictably along rails. In reality, every drone jerks up, down, left, and right in random evasive movements every second or two. Their fiber optic tails flash and vanish like spider silk in sunlight. He is chasing phantoms that change direction faster than he can adjust. He walks his bursts across open sky, but by the time his tracers touch a path, a drone once occupied, the machine has already slid somewhere else. 8 seconds after he starts firing, the swarm disappears behind a line of trees, leaving nothing but empty branches and drifting smoke. His commander slams a fist against the hatch rim, frustrated and powerless to report the failure, his radio still choked with friendly jamming. The drones, untouched, continue to close, now only a few kilometers from the part of the track the Ukrainians have named simply the window. That window is a stretch of line where the rails run straight through open country for several kilometers, away from heavy defenses, away from urban cover, and away from overhead protection. The Ukrainians watch this section for weeks through satellites and scouts, measuring timing and speed. They know how long a train will remain exposed here. They know which side roads lead to it. They know that in this brief corridor, the train is naked. The artillery rounds continue to fall behind them, but those echoes are growing less frequent, the guns shifting fire, unsure if the target is still there. At the edge of that corridor sits the Russian air defense system, tasked with making sure no threat reaches the rails. Its search radar struggles to distinguish the tiny drones from ground clutter and heat shimmer, so the crew switches to optical tracking. On their screen, the swarm appears as a loose cluster of flickering specks. The operator selects gun mode. Under the turret, twin 30mm autocannons spool up, each shell pre-programmed to detonate, not on impact, but at a specific distance, turning single rounds into expanding clouds of steel fragments. The gunner knows he cannot afford to aim at individual drones. They are too small, too agile, and too numerous. Instead, he paints the sky with calculated volumes of shrapnel. At a few thousand meters, the first string of shells erupts in mid-air, each one bursting into hundreds of razor fragments. One of the drones simply disappears in a white flash, its video feed cutting to static. A second is torn apart seconds later, its last frame showing streaks of metal rushing toward the lens. The remaining drones react as if they were stung. On the Ukrainian side, the operator responsible for overall coordination orders an immediate split in 3 dimensions. 3 drones climb sharply, presenting darker silhouettes against the sky. 3 drop so low that their propellers almost comb the tops of the grain stalks. 1 holds an intermediate altitude, sliding sideways in erratic movements, a decoy in open space. The air defense computer flags the higher group as easier to track. Training doctrine insists that the closest threat should always take priority. The gunner has only a heartbeat to choose between instinct and algorithm. He raises the barrels toward the climbing drones, committing to the path his computer recommends. In that moment, the low group races forward, almost untouched, hugging the folds of the terrain and taking advantage of every blind angle. By the time the gunner senses the mistake and tries to swing his guns down, the low drones are already beneath his optimal engagement arc, slicing into a region of space his weapons cannot cover. Without redesigning the turret ring, the system has been built to fight cruise missiles and fast jets, not slow insects crawling along the ground. Along the line ahead, a small Russian observation post sees the drones coming and adds its own fire. Dozens of rifles and light machine guns snap from their rests as soldiers aim at the sound of buzzing engines. The geometry is unforgiving. The drones are crossing perpendicular to their firing line, moving at the speed of a car on a highway, but much closer and much smaller. Human reaction time eats a quarter of a second before a trigger finger even tightens. Aiming adjustments take another fraction. By the time a sight picture settles on a target, it has already moved on. Tracer rounds stitch the air behind the drones, painting straight lines where curved solutions were needed. Some soldiers fire rocket-propelled grenades upward, hoping to detonate near the swarm, but the fuses and trajectories were never meant for small aerial targets. The explosives burst in impressive fireballs with no practical effect. While that chaotic curtain of fire burns itself out, 4 of the Ukrainian drones that have been loitering at higher altitude peel away from the main axis, banking in a tight arc toward a segment of track far behind the moving train. Those 4 machines are not aiming for the train at all. They dive toward the rails themselves, targeting a section several hundred meters behind the last wagon. On approach, each drone releases a small, dense canister. On impact, the canisters crack open and pour out a stream of material that does not explode so much as ignite in an almost blinding white glare. It is a mixture of metal powders and oxidizer designed to reach temperatures that ordinary explosives cannot match. Where it touches steel, the rails do not bend or crack. They begin to burn. Railroad steel softens and fails at temperatures lower than that sustained by the burning mixture. Within moments, neat parallel lines of heavy metal are transformed into molten gaps, sagging and collapsing under their own weight. To a train approaching at speed, the rails will appear intact until the very last seconds. Structurally, though, they are already gone. The drones that delivered the charges have already expended their payload and value. Their sacrifice was planned into the mission profile from the beginning, one set of tools to prepare the ambush for another. Back at the air defense system, those twin cannons have been firing at near maximum rate. Modern autocannons can maintain extreme output for a short burst. If firing continues beyond a safe threshold, the rifling inside the barrels warps. Rounds begin to tumble instead of spin, spraying unpredictably and chewing up the guns from the inside. The gunner has to make a choice between continuing ineffective fire or pausing. He releases the trigger. For a dozen seconds, the sky near the train is free of large-caliber fire. The surviving drones push forward, batteries draining faster than planned as they fight both distance and wind. On their control screens, icons begin to flash amber as charge levels fall into critical ranges. One drone shows less than 1/5 capacity. Another drops toward that threshold. The operators know exactly how many seconds of flight remain at their current power draw. They also know it is barely enough to cover the distance if nothing else goes wrong. Smoke from the burning rails and ignited grass is now drifting across the battlefield, pushed by a light crosswind. That smoke carries carbon particles that absorb infrared energy across a wide range of wavelengths. Thermal cameras that could easily see through darkness and rain now stare into an opaque gray wall. Russian positions lose their only reliable way to track the drones. For a brief window, the aircraft are not just small and agile. They are effectively invisible to anything that is not close enough to hear their electric motors whining in the air. As the drones emerge from the far side of the smoke, they are less than 2 kilometers from the train. Every bolt, rivet, and identification number on the wagons is visible on their feeds. The fiber optic lines trailing behind them are nearing their own limit. Each reel holds a fixed length of glass filament. Beyond that, tension rises and tangles become a threat. To prevent a tether from snapping at the worst moment or dragging on obstacles, each line is rigged to release automatically once it reaches a predetermined extension. Meters tick down on a small indicator in the operator's field of view. When the line plays out, a simple mechanical latch opens and the fiber falls away, whipping back toward the earth. One drone drops its tether a few meters earlier than expected as the spring lets go. Instantaneously, its control link shifts from fiber to radio, and its battery display drops into single digits. The others follow over the next few seconds. All remaining drones are now exposed to jamming, but they are also close enough that inertia, if properly used, can carry them to the target. In the locomotive at the front of the train, the engineer finally sees the incoming threat clearly, a cluster of dark shapes rising and falling over the tracks ahead. He pushes the throttles beyond their designed limit, overpowering mechanical stops. Diesel engines roar as injectors flood cylinders with fuel. For a few heartbeats, the speedometer nudges higher. Then physics takes its own revenge. Steel wheels on steel rails can grip very well under controlled load, but once they begin to slip, the friction curve collapses. The driver is now polishing the track instead of pushing against it. Hidden under the forward part of the train, the air defense system attempts one last engagement. The drones have crossed into its minimum effective range. The guns cannot depress far enough to fire on targets that low and that close without hitting their own protective berm. The system has been optimized to shoot at threats coming from above, not level with the track. The operator can only watch his screen as the drone tracks drop below his engagement arcs, sliding into a blind spot defined not by enemy cunning, but by simple angles and engineering constraints. Russian troops near the final checkpoint throw everything they have into the air. Machine guns vibrate on bipods, rifles snap, and more rocket-propelled grenades arc upward. The drones stay centered over the railway, directly above the line of wagons. Soldiers would need to fire through their own train, punching holes in the very cargo they are there to protect. Few are willing to take that risk. Most rounds pass wide or high. Some ricochet off metal sides. One drone takes a glancing hit that cracks its battery casing and tumbles into a field, spent. Another drone suffers a different kind of failure. Its battery monitor hits zero while it is still a short distance from the target. The electric motor cuts out abruptly, propellers turning into windmill. Yet momentum has no need for power. The drone continues forward on its existing velocity, losing height only slowly over the last stretch. In the control bunker, the operator watches the final video feed as the image jitters and drifts. Guided now only by the balance between drag and inertia, no longer an aircraft, but not yet wreckage. Behind the drifting dust and shuddering steel, the final wave arrives. One drone slams into the coupling between the locomotive and the first wagon, its shaped charge punching a narrow jet of molten metal straight through hardened steel. A heartbeat later, more impacts ripple across the train. Fuel lines rupture into vapor. brake systems seize, an ammunition wagon. Its internal seals, weakened by days of vibration, takes a direct hit that forces its temperature past the point of ignition. The resulting blast is not an explosion so much as an eruption, a pressure front racing outward faster than sound. Entire wagons vanish into incandescent fragments. Others lift from the tracks and tumble across open fields in twisting arcs. In seconds, what had been thousands of tons of cargo becomes a cratered scar along the rails and a rising plume of smoke. A handful of lightweight drones, costing barely more than a family appliance, have erased a vital artery, feeding multiple Russian formations, and ended the voyage of a train meant to hide its purpose behind routine movement. The rails collapse into molten gaps, the sky fills with drifting embers, and the battlefield settles into a stunned silence broken only by the crackle of burning metal. The mission, built on precision, endurance, and relentless adaptation under fire. At number 6, we have an operation which Russian generals laughed about, but until a MiG-31 and Kinjal attacked them off guard. Let's watch. At 6:14 a.m., a MiG-31K Foxhound sits on a rough strip in southern Ukraine with its canopy shut and its engines screaming, while the far end of the runway collapses into flame as Russian Iskander missiles hammer the concrete in staggered impacts that walk closer with each second. Captain Alexei Volkov has no room to taxi, no time to shut down, and no safe direction to run, because the jet under him is not just an aircraft anymore. It is a nuclear-capable delivery platform carrying a Ku-47 M2 Kinjal hypersonic missile. And every sensor in the region is hunting it like a beacon that refuses to dim. The problem is that surviving the ground strike is only the first gate, not the last one, because the moment he lifts off, he will be inside the engagement envelope of an S-400 Triumph battery that already has a track on his departure corridor. If he stays, the runway becomes a furnace, and the jet becomes scrap. If he climbs, the radar lock becomes a countdown with no mercy. And a 48 N6 interceptor can be airborne and accelerating to Mach-class speeds before he finishes retracting his landing gear. This is the kind of choice that turns pilots into statistics, unless the pilot is willing to do something that sounds like madness, even in a war room. To understand why a Russian captain is gambling his life on Ukrainian soil, the clock has to rewind 4 hours to the Black Sea, where the same MiG-31K was cruising at 40,000 feet on a routine patrol line that looked boring on purpose. The Foxhound is often called a fighter, but the way it is described in this scenario makes it closer to a pair of enormous engines with a cockpit attached, built to climb, point its nose straight, and go very fast. On a clean day, it can push toward nearly 1,900 miles per hour, but today it is dragging a 4.3-ton missile under its belly, and the drag changes everything. With that Kinjal mounted underneath, the jet becomes heavy, stubborn, and thirsty, like a sprinter forced to carry a grand piano while trying to keep up with a pack of racers who are unburdened. The aerodynamic penalty is constant, and the fuel burn is the kind that makes planners stare at maps like they are negotiating with physics. Volkov knows this better than anyone because he can feel it in the controls, in the sluggish response, and in the way the aircraft resists every small correction. But he also knows something else, something the Russian controllers watching their screens do not know yet. The weight under him is not just a weapon, it is leverage. Months earlier, this mission began as encrypted conversations with Ukraine's military intelligence, the kind that never appear in official briefings until long after the people involved have disappeared into new identities. Volkov had been flying patrols as part of a system he no longer believed in, and the scenario frames his decision as a trade between a dictator's reward and a clear conscience. The deal was simple in concept and brutal in execution. Bring the aircraft, bring the missile, and cross a line that cannot be uncrossed. In exchange, Ukraine would build a trap corridor through surveillance, deception, and timing, because a lone jet cannot outrun a nation once the alarms begin. The moment the plan becomes action, it happens without radio chatter or hesitation, because any hesitation would be read as weakness by the same air defense network he is trying to evade. Volkov slams the stick forward, and the Foxhound pitches over into a steep dive, trading altitude for speed as the sea rushes up to meet him. Instead of turning back to base, he drives straight toward Ukraine. And the change is so abrupt that the air defense picture in Crimea lights up like a warning panel. For a brief instant, the Russian controllers wonder if it is a malfunction or a medical emergency, because pilots do not usually do this on purpose. Then he levels out at roughly 50 feet above the water, turns off his transponder, and forces the situation to reveal its true nature. At that altitude, the curvature of the Earth becomes cover, and ground-based radar lines lose clean sight of him. But the margin for error shrinks to nothing. Fly higher and he is visible. Fly lower and a wave can end the story in one violent roll. Salt spray is so close it feels like it is trying to sandblast the canopy, and the jet's stability becomes a constant negotiation between speed, lift, and the drag of the missile, acting like a giant air brake. He is betting that the radar shadow will hold long enough to reach the next layer of the trap. Russia does not treat it as a misunderstanding for long, because the object moving south is not a normal aircraft. It is a strategic system, and the scenario makes clear that the Kremlin realizes its invincible nuclear delivery asset is being stolen. 4 Su-35 flanker fighters scramble from Crimea, and that changes the geometry instantly, because the Su-35 is described as a modern, super-maneuverable dogfighter operating clean, light, and fast. Unlike the Foxhound dragging its belly weight, these jets can accelerate hard without paying the same penalty, and they carry R-77 radar-guided missiles with the reach to strike from far outside visual range. Volkov cannot win a straight race, and he cannot outturn a missile shot if he tries to fight like a conventional fighter pilot. So the script leans into physics as his only weapon. He stays glued to the sea, using surface clutter and Earth curvature to degrade the Russian targeting picture, and he forces the Su-35s to solve a harder problem than they expected. Their radars sweep the ocean surface, looking for a reflection that keeps disappearing into the noise, and the gap closes anyway, because clean jets closing on a dragged aircraft is not a debate. Inside the cockpit, the strain shows up as vibration, heat, and the awareness that his fuel is draining faster than the math wants to admit. The first unmistakable warning arrives as the radar warning receiver screams, and the tone signals an N035 class lock, meaning the lead Su-35 has finally pinned him. There is no negotiation, no demand to return, and no request for surrender, just a launch as 2 R-77 missiles fall away and ignite, switching into the kind of active homing hunt that does not care about bravery. Volkov has seconds, and with a 4.3-ton missile hanging under him, he cannot dance. So he chooses a move that is almost suicidal at wave-top height. He chops the throttle, deploys air brakes, and decelerates violently to confuse the Doppler solution. For a heartbeat, the missile's tracking logic loses the clean closure picture it expects, and his radar return blends with the waves below, just long enough for the shots to streak past and detonate in the water ahead. It is a narrow escape that creates an even worse position, because now he is slower, still low, and the remaining Su-35s are closing with anger instead of procedure. The near miss tells them he is deliberate and capable, not panicked, and that makes them dangerous in a different way. As they spread to box him in and push toward gun range, Volkov is running out of airspace, out of fuel margin, and out of time to reach the hidden hand Ukraine promised would appear. The turning point arrives when the MiG-31 reveals that it is not defenseless cargo, but a platform with teeth, because under its wings it still carries R-37M long-range missiles, designed for killing bombers at distances that feel unfair. These missiles are heavy and not elegant, but their warheads are enormous, and their purpose is simple. Volkov overrides low-altitude launch safeties that exist to protect pilots from themselves, because safety is no longer part of the equation. He pulls the nose up just long enough to be seen, deliberately exposing himself to enemy radar as bait, knowing that aggression is predictable when pride is involved. The lead Su-35 takes the invitation exactly as expected, diving in for what looks like a guaranteed kill against a slow, burdened interceptor. Volkov fires one R-37M head-on, and the missile leaves the rail like a thrown telephone pole, accelerating with purpose rather than grace. It does not need a direct hit because its 132-pound warhead is designed to shred large aircraft. When it detonates roughly 98 feet in front of the Su-35, the result is instantaneous disintegration as shrapnel and overpressure tear through the airframe, sending the wreckage tumbling into the Black Sea below. The victory is real but fleeting, because the explosion is also a beacon that hands the remaining 3 Su-35s his exact location. Their response is not cautious, it is personal. They spread wide, abandon long-range shots, and push throttles to close within visual range, intending to finish the job with cannons rather than missiles. From their perspective, the Foxhound is a wounded animal, dragging dead weight, and the border is still minutes away. Inside the cockpit, engine temperatures climb toward red lines, sweat blurs vision, and the vibration never stops. Because pushing the MiG this hard with that payload is like forcing metal to argue with itself. 2 minutes of survival is all the missile kill buys him, and 2 minutes is not enough to cross into safety. The Su-35s begin herding him away from the Ukrainian coast, forcing angles that favor their agility and denying him the straight-line escape he needs. They are not rushing anymore, they are controlling. The 30mm cannons under their noses are designed for exactly this kind of finish, and they are waiting for the cleanest shot. The scenario emphasizes that at this stage, skill alone is not enough. Volkov needs an external disruption that changes the entire picture, not just his own flight path. That disruption appears the moment he crosses an invisible boundary in the sky, because Ukrainian planning has been waiting for this geometry. Without warning, the radar scopes inside the Russian fighters flood eye with contacts, transforming a single target into what looks like an entire squadron materializing out of nowhere. Confusion ripples through their formations as pilots call out multiple returns that do not behave like real aircraft, but are impossible to filter cleanly. This is the deployment of 12 modified AQ-400 Scythe drones, each carrying a Lundberg lens that amplifies radar reflection until a cheap airframe looks like a 20-ton fighter on scope. Mixed into this cloud of false targets are electronic warfare pods, blasting noise across the X-band frequencies the Russian radars depend on, saturating tracking computers that are designed for precision, not chaos. The effect is deliberate overload, rather than brute force jamming, and it works because it forces the Su-35s to solve too many problems at once. Locks break, reacquire, and break again. And targeting solutions never stabilize long enough to fire with confidence. To the Russian pilots, the sky has turned into a hall of mirrors where every contact could be real or could be a ghost. Volkov uses the confusion exactly as intended, pushing his throttles past limits that maintenance manuals exist to prevent, because manuals assume you plan to land the aircraft intact. He dives directly into the heart of the drone swarm, merging his signature with theirs so completely that on radar, he becomes just another identical return. A panicked Russian pilot fires his last pair of R-77 missiles at what looks like a heavy fighter, closing head-on, only to destroy a cheap drone built from plywood and foam. $1 million weapons vanish into explosions that achieve nothing, and that waste creates the opening Ukraine calculate. With the Su-35s busy chasing ghosts, the Foxhound slips through and drops its landing gear as a hidden forward operating base in southern Ukraine appears ahead. The runway is short, uneven, and never designed for an interceptor this heavy, especially one still carrying a hypersonic missile. The landing is hard and violent. Tires scream, smoke pours from overheated brakes, and the drag chute snaps open as the jet chews through concrete with meters to spare. When the aircraft finally stops, the silence is disorienting, because after hours of sustained stress, the absence of motion feels unreal. The relief lasts less than half a minute before sirens begin to wail across the airfield and a Ukrainian ground crew chief runs toward the jet, not with congratulations but with urgency. Engines stay running, because shutting down would cost time they do not have. A Russian reconnaissance satellite has already passed overhead, and the landing was visible from space. 200 miles away, An Iskander missile battery has received fresh coordinates and authenticated launch orders. The missiles are airborne before anyone on the ground finishes saying the words time to impact, which is 7 minutes. 7 minutes is barely enough to think, let alone refuel a MiG-31. But the Ukrainian crew swarms the aircraft anyway, performing a hot pit refuel that turns the tarmac into a potential inferno. Fuel hoses connect while engines spin and burn hot, and every spark becomes a threat that nobody has time to fear. In the middle of this controlled chaos, a young officer in a mismatched uniform sprints toward the cockpit carrying a ruggedized laptop, like it is the only thing that matters. This is Lieutenant Dnipro, 24 years old, a specialist whose battlefield is code rather than altitude. He does not waste words explaining rank or protocol. He tells Volkov that the Kinjal is geofenced, locked by Russian software to prevent firing into Russian territory, and that if it is triggered without authorization, it will brick itself and become a 4.3-ton dead weight. The missile, as delivered, is obedient even in betrayal. Dnipro climbs into the rear seat and connects directly to the MiG's mission computer, bypassing anything that resembles a clean procedure, because the solution is not elegance, but deception. Instead of writing new code, which would take time they do not have, he inserts a pre-programmed hardware override chip supplied through Western intelligence channels. The chip carries a spoofing algorithm that lies convincingly to the missile's guidance brain, telling it that its target is a harmless practice range in the Pacific Ocean. While the missile believes this fiction, its inertial coordinates are quietly rewritten to point back toward the Russian radar that will soon try to kill them. The deception does not break the rules of the system. It obeys them in a way the designers never intended. As Dnipro races against the clock, the first Iskander impacts at the far end of the runway, sending a shockwave across the field that rattles teeth and shreds concrete. Another impact follows closer, and the explosions begin to march toward the aircraft. Fuel hoses are ripped free by hand as Volkov slams the canopy shut and pushes throttles to full military power. The MiG lurches forward, heavy with fuel and still carrying the missile, as the runway behind them disappears into fire and debris. The takeoff becomes a race against explosions that are literally chasing the jet down the concrete. The nose lifts east as the section of runway they occupied a second earlier disintegrates, and the Foxhound claws into the air under full afterburner, blue fire erupting from its tailpipes. They are airborne, but the danger only shifts shape, because the moment they climb, the Russian S-400 Triumph battery across the border locks on. Its Big Bird radar paints them cleanly, and a 48 N6 interceptor erupts from its canister, accelerating to Mach-class speeds as it hunts from behind. Inside the cockpit, Dnipro calls out the radar type and bearing, and Volkov understands that outrunning this missile is not an option. Volkov reacts by pulling the MiG-31 into a steep climb, trading speed for altitude, because altitude is the only currency that can buy him a launch window. The interceptor missile behind them is optimized for targets that run, not for targets that suddenly climb like an elevator. As the Foxhound roars upward, its belly is fully exposed to the enemy radar, but exposure is no longer the threat it was seconds ago. This climb is not an escape. It is preparation, and the aircraft strains under forces it was designed to endure only in short bursts. Inside the cockpit, warning tones overlap as airspeed bleeds off and engine temperatures flirt with limits that engineers assume pilots will respect. Volkov ignores them because the alternative is simpler and worse. He flips the master arm switch, and the aircraft responds with a physical shudder as 4.3 tons of missile detach from its belly. The Kinjal's solid rocket motor ignites in a flash that briefly outshines the jet itself, and the hypersonic weapon arcs upward before curving back toward the border it was never supposed to face. Two missiles are now racing on intersecting paths, each trying to decide who lives next. The S-400 interceptor continues closing from behind, its guidance fed by the Big Bird radar that has tracked hundreds of targets without mercy. Dnipro watches numbers scroll across his screen, confirming that the spoofing algorithm is holding, and that the Kinjal believes it is executing a routine test profile. In reality, its inertial navigation is locked on a radar vehicle that is still transmitting confidently, unaware that its own emissions have just signed its death warrant. The sky over the border becomes a corridor of pure velocity. The interceptor missile is fast, but the Kinjal is faster, screaming down from the stratosphere at speeds measured in thousands of miles per hour. Russian radar operators have no meaningful warning window because hypersonic timelines collapse decision cycles into moments that feel like glitches rather than events. The Kinjal slams directly into the Big Bird radar vehicle, and the impact vaporizes it so completely that the command post disappears in the same instant. The shockwave flattens equipment, vehicles, and any illusion of control that existed seconds earlier. With the radar gone, the interceptor missile chasing Volkov loses its guidance input and goes blind, veering off into empty sky before detonating harmlessly far away. In the cockpit, the radar warning receiver falls silent, and the absence of noise is confirmation enough. The engagement is over, not because the MiG outran its hunter, but because the Archer was removed from the equation entirely. The cost to Russia is immediate and measurable. One Su-35 fighter lies at the bottom of the Black Sea. One hypersonic missile designed to intimidate rivals has been turned back on its own defenses. 400 battery, valued at roughly $500 million, is reduced to wreckage in a matter of seconds. On the Ukrainian side, the gains extend beyond survival. A MiG-31K Foxhound, intact and flyable, now sits in friendly hands, along with the technical knowledge embedded in its systems, procedures, and maintenance realities. The aircraft is no longer a symbol on a poster or a threat in a briefing. It is a machine that can be studied, understood, and neutralized in future planning. The intelligence value alone reshapes how planners think about interception, hypersonic delivery, and the limits of deterrence built on secrecy. Volkov's defection is framed not as a spontaneous act, but as the endpoint of months of quiet preparation, and the narrative emphasizes that no amount of technology can fully compensate for a human decision made under pressure. Electronic warfare, drones, spoofing chips, and hypersonic physics all mattered, but none of them would have activated without a pilot willing to cross a line that cannot be erased. In that sense, the operation becomes less about a single escape and more about the vulnerability of systems that assume loyalty as a constant. The scenario also underlines how modern air combat has shifted away from simple contests of speed or maneuverability into layered struggles involving sensors, software, and deception. Radar range means nothing if the picture is flooded with ghosts. Missile speed means nothing if the guidance chain can be severed. Even satellites, watching patiently from orbit, only compress timelines rather than guaranteeing outcomes. Each layer adds power, but each layer also adds a new surface for exploitation by an adversary willing to think asymmetrically. For Russian planners, the aftermath is not just a tally of losses, but a crisis of trust. Units operating Kinjal systems are reportedly pulled back and rechecked, not because the missile failed, but because someone used it differently than intended. Commanders are forced to consider whether other digital leashes exist and whether those leashes can be cut just as quietly. The fear is not that technology is weak, but that it depends too much on assumptions about who is holding the controls. For Ukraine, the operation becomes a case study in how limited resources can be amplified through timing, preparation, and an understanding of enemy doctrine. 12 inexpensive drones equipped with reflectors and noise were enough to neutralize elite fighters long enough for one jet to pass. A single hardware chip and a prepared algorithm were enough to turn a strategic weapon into a liability. The narrative consistently frames these choices as deliberate rather than lucky, emphasizing planning over improvisation. The human element remains central all the way through. Dnipro's role as a young specialist highlights how modern warfare increasingly relies on people who may never fire a weapon, but whose decisions carry strategic weight. His intervention lasts minutes, But those minutes decide whether the missile is dead weight or decisive leverage. The story avoids romanticizing chaos, instead showing competence under pressure as the true differentiator when seconds matter. As the MiG-31 disappears deeper into Ukrainian airspace, the immediate danger fades, but the implications do not. Air defense networks on both sides will be studied, modified, and hardened. Software assumptions will be questioned. Training scenarios will change. The event does not end a war, but it alters how both sides think about the relationship between technology and loyalty, and about how asymmetric thinking can puncture even the most confident claims of invulnerability. In the end, the scenario closes on a simple but uncomfortable conclusion. Advanced systems can dominate a battlefield, but they cannot decide why a person climbs into a cockpit in the first place. Now we have number 5. A $5 billion Russian T-90 tank factory powered up, but Ukrainian bombs rain on them within minutes. Let's watch. At 3:17 a.m. on December the 3rd, 2025, the lights inside Uralvagonzavod burned at full intensity as night shift crews in Nizhny Tagil wrestled steel into shape for new T-90 turrets, unaware that Ukrainian planners had spent months waiting for this exact moment. Russia had poured roughly $5 billion into pushing the plant into round-the-clock production, upgrading substations, hydraulic lines, and casting halls so every press stroke and welding arc drew as much power as the grid could deliver. That peak electrical load was not a coincidence to Kiev. It was the condition for maximum damage, somewhere over the snowbound fields near the Sumy border, far beyond the factory workers' horizon. The opening move of the operation had actually begun 14 hours earlier, when the first of 48 modified long-range drones clawed their way into a blizzard that would hide them from human eyes, but not from mathematics. Those airframes were not standard off-the-shelf models. Ukrainian engineers had stripped them down to bare composites, extended their wing, and bolted on external conformal fuel tanks that turned modest attack drones into cross-border strike assets. With that extra fuel, each machine could cover roughly 1,250 miles, more than enough to loop around Russian radar belts, instead of trying to punch straight through. Flying at barely 40 feet above the frozen ground, their small propellers pulled them through the whiteout at speeds slowly adjusted to match the terrain. Instead of pilots sweating over yokes, guidance computers fused input from CRPA anti-jam antennas and laser altimeters that scanned ahead hundreds of times per second. The antennas listened for satellite signals and threw away anything that looked like electronic interference, while the altimeters painted invisible lines down the slopes and up the ridges, letting the drones hug the contour. The route planners had treated Western Russia not as a flat map, but as a three-dimensional maze of overlapping detection cones. S-300 and S-400 batteries guarded the industrial heartland with overlapping fan shapes of search radar, while shorter-range systems and mobile Panzer S-1 units filled in the gaps. On a two-dimensional chart, that wall looked solid. But the Ukrainians had spent months combing satellite imagery, signals intercepts, and open-source maps to find the seams between coverage lobes. The solution was counterintuitive. Rather than skimming along the edge of the belt, the swarm would dive under it, using mountain valleys and forested lowlands in the Ural region as a kind of radio shadow. The blizzard helped, scattering radar energy with billions of ice crystals, but it was a bonus, not a crutch. The machines were built to survive even on a clear night. The storm simply made their odds better. By 3:10 a.m., the first phase of the plan reached its critical moment above the southern approaches to Nizhny Tagil. 18 Beaver-type decoy drones, stripped of heavy payloads and fitted with Lundberg reflectors, climbed away from the main formation and executed a starburst maneuver over the designated engagement zone. To the naked eye, they were just dim shapes vanishing into cloud. But to the 92 N6E fire control radar of the nearby S-400 battery, each reflector ballooned their radar cross-section into something that looked very much like a Storm Shadow-class cruise missile. 18 separate hostile tracks bloomed on the Russian operator's scope, all closing on what the algorithms considered a strategic industrial asset. The system's logic tree was simple and ruthless. Rank threats by range and apparent size. assign interceptors, and fire without hesitation. Two 48 N6DM interceptors left their canisters first, followed by more as the software calculated new trajectories. Each missile was a 4,000-pound weapon built to swat hypersonic targets at high altitude, now being burned on fiberglass bodies, moving at propeller speed inside a snowstorm. Solid fuel motors drove them to Mach 4 in seconds as their active radar seekers locked onto the bright reflections from the decoys. Below, Panzer S-1 crews at a site the Ukrainians had labeled Position Alpha watched their local scopes fill with symbols and heard their fire control computers call out target tracks faster than human voices could repeat them, unable to trust their jammed displays. Some operators switched to 30mm autocannons, hosing the blizzard with high explosive shells that traced glowing lines through the storm in frantic arcs. From a purely tactical perspective, the Russians seemed to be winning. By 3:13 a.m., burning fragments of decoy drones were scattered across the snow around the southern perimeter of the plant, and the S-400 site had logged 18 kills. Yet those victories carried an invisible cost. The battery had expended 12 long-range missiles, depleting 3 of its 4 launch tubes, while both Panzer units guarding that sector were completely dry on ready 30mm ammunition and halfway through their short-range missile stocks. Their crews were still wrestling heavy rounds into freezing magazines and reprogramming guidance settings when their scopes finally showed a clear sky. Believing the threat had been neutralized, the sector commander began to compose a report of successful defense, unaware that he had just traded his best ammunition for empty air and opened a gap that Ukrainian planners had designed into the timeline from the start. 3:14 a.m. marked the beginning of the second phase. 12 more Beaver-derived drones, outwardly similar to the decoys but modified for a very different role, slid into a holding pattern at roughly 1,500 feet above the complex. Each carried a 15-pound disposable jamming pod slung under its belly in place of a warhead, powered not by long-life batteries, but by capacitors tuned to dump their entire energy load in roughly 6 minutes. When the Ukrainian controller sent the activation code, the ring lit up in the electromagnetic spectrum. The pods blasted out carefully shaped noise across the L-band and X-band frequencies used by Russian surveillance and engagement radars. To the operators on the ground, the effect was like having a floodlight aimed directly into night vision goggle. The previously clean screens turned into blizzards of static, in which every pixel seemed to flicker with phantom echoes. Standard Russian doctrine called for switching to optical or infrared tracking when radar data became unreliable, and that is exactly what the factory's defenders tried to do. Panzer crews slewed their electro-optical turrets toward the humming they could hear above the storm, and switched through visible and thermal modes in search of silhouettes against the clouds. On any other night, this fallback would have given them at least a fighting chance. But the same blizzard that had helped conceal the inbound swarm now conspired to blind the cameras. Dense snow simply blocked visible light, turning the video feeds into gray curtains of swirling particles, while 20-mile-per-hour winds stripped heat from the slender composite airframe so efficiently that their infrared signature blended into the background sky. In the command van of the S-400 battery, officers tried to reboot radar subsystems and narrow beam widths to cut through the noise, but failed. The final twist of the jamming plan emerged only when Russian crews obeyed an order that technically violated their own safety rules. Faced with the knowledge that their radars were blind and their cameras nearly useless, the sector commander gave a desperate instruction over the net: ignore standard engagement envelopes and fire missiles at the jamming sources overhead as soon as any kind of lock could be achieved. Panzer units obeyed, rippling off 57 E-6 missiles in optical mode at close range, while a neighboring Tunguska battery added quad 30mm cannon fire that stitched orange lines into the low clouds. The jamming drones were not programmed to dodge. Their purpose was to die at the right moment. One after another took direct hits and disintegrated. Yet instead of clearing the air, their destruction triggered the next layer of the trap, because inside each supposedly simple pod lay tightly packed bundles of metallic chaff strips and a small magnesium. At the moment of destruction, Each charge blossomed into a cloud of glittering metal fragments that scattered across the sky and burned brightly for several seconds before cooling into reflective debris. Millions of tiny strips drifted downward through the storm, overwhelming the returning radar pulses of every system trying to recover from the jamming. Instead of a handful of drones, Russian computers now saw what appeared to be entire swarms of high-speed objects falling simultaneously across the engagement zone. Two Panzer systems suffered immediate software crashes as their processors attempted to track thousands of false returns, forcing their turrets to droop into emergency reset. Even the larger S-400 array froze mid-sweep, leaving only manual optical modes available. For the next 60 seconds, what had been advertised for years as an impenetrable aerial shield was reduced to blind metal amid the snowfall. At 3:17 a.m., as the last shards of metallic chaff drifted toward the roofs of maintenance sheds and assembly bays, the third wave arrived. 18 Lutyi-class strike drones, their 14-foot frames built for load-bearing rather than stealth, surged into the undefended perimeter at barely 50 feet above the tree line. Each machine housed a Honeywell-grade laser ring gyroscope that tracked positional drift with deviations measured in mere feet per hour, ensuring reliable guidance even with every form of satellite navigation turned to noise by their own electronic warfare pods. Slung beneath each drone was an 820-kilogram warhead, engineered to open armored structures rather than vehicles. A shaped charge design that turned explosive energy into a focused jet able to pierce steel, concrete, and the layered plates of large industrial presses. The first of the three groups, labeled by Ukrainian planners as the Alpha element, veered hard left toward the 500 kilovolt substation, positioned along the plant's southern edge. That substation funneled enormous electrical loads into the forge halls, powering the 25,000-ton hydraulic presses that had only recently resumed work under upgraded wiring rated for sustained maximum output. As the leading Alpha drone pointed its nose downward, the shape of the transformer complex glowed prominent in the drone's targeting algorithms, which recognized heat gradients and structural outlines even through snow. When the shaped charge warhead struck the ceramic casing of the main transformer, the resulting arc flared blue-white, hotter than the surface of the sun, vaporizing cooling oil and sending an electrical surge cascading across the internal conductors. Inside the cavernous press hall, workers felt the floor tremble a heartbeat before the lights died. 50,000 gallons of high-pressure hydraulic fluid rested inside the lines, feeding two giant presses. And when Team Bravo of the strike drones breached the roof from 500 feet above, those lines became the weakest link. The first Bravo drone knifed through a skylight and buried its warhead into the central cylinder of press number 1. The copper liner inverted upon detonation, producing a jet moving at tens of thousands of feet per second that sliced through steel like fabric. The explosion forced steel doors from their hinges and hurled debris across the production floor. Seconds later, the second and third drones followed, their charges targeting the companion press. Heat built so rapidly inside the hall that structural columns deformed. While those detonations shook the interior of the complex, Team Charlie completed the outer phase of the strike. 10 drones streaked between storage sheds and open yards, where T-90 hulls waited in rows for paint and final assembly. Despite the heavy armor, the drones ignored the thickest plating, instead locking onto engine compartments, access hatches, and fuel inlets. One drone's detonation cascaded across 3 adjacent hulls when stored lubricants flashed into flame. Within moments, the yard looked like a line of failed suns casting long shadows over the snow as fresh flakes melted mid-air before reaching the ground. The operators in their remote bunkers monitored telemetry until each drone confirmed impact, then shifted to thermal feeds to assess damage patterns spreading across the site. When the final warhead detonated, the blast reverberated across the silent factory grounds. The S-400 battery's radar systems completed their reboot only after the decisive strikes had already occurred, leaving crews staring helplessly at the flare of heat blooms smeared across their displays. By then, the hydraulic presses were irrecoverable, their housings warped, cylinders collapsed, and internal precision surfaces cooled into misaligned forms that could not be machined back to tolerance. Those presses were 2 of only 4 such machines within the Russian Federation, each required for forging single-piece turret rings capable of withstanding impacts better than welded alternatives. Without them, production would revert to 1955 methods, forcing turret assemblies to be cast in smaller sections and welded together. That process tripled production time and reduced armor integrity, by roughly 40%, a regression that rippled outward to every contractor. Analysts in Kiev estimated that the attack brought at least half a year of reduced pressure on Ukrainian frontline units, granting breathing room measured not just in time but in avoided casualties. By 6 a.m., as snow continued falling over the skeletal remains of the press hall, videos recorded by stunned workers began circulating across encrypted channels and then emerging on open networks. Grainy clips showed the factory in total darkness, punctuated only by fires still smoldering among the debris. The myth of the Ural fortress, long held as a symbol of industrial resilience, seemed to unravel in real time. Citizens questioned how a facility considered one of Russia's safest assets had fallen in less than 2 minutes. Defense officials attempted to explain away the failure by citing unprecedented weather and unusual tactics, but the images told a different story. An undefended industrial giant struck with surgical precision despite layers of expensive protection. Somewhere in Moscow, planners faced the sobering arithmetic of $2 million spent against billions in losses, and the realization that the battlefield had expanded deep into territory once thought unreachable. At the same moment, officials drafted internal briefings. Ukrainian analysts pored over telemetry captured throughout the operation. The recordings showed how each phase had aligned with precise timing, from the low-altitude penetration of the first wave to the artificially induced radar blindness that opened the door for the Luty-class drones. Those 820-kilogram warheads, originally tested for penetrating hardened Dnipro, had performed beyond expectations when striking equipment under full operational load. Structural stresses, elevated temperatures, and active hydraulic cycles had all magnified the destructive potential. Engineers reviewing the footage noted that the press hall's failure initiated not only from the shaped charge penetrations, but from thermal gradients tearing metal apart faster than any tool could follow. The attack was more than a strike. It was a controlled industrial collapse executed under cover of snow. Inside Ukrainian command centers, operators watched the aftermath unfold with analytical calm. Each drone's final telemetry suggested how environmental conditions had influenced its guidance, revealing subtle drift patterns that would be corrected in future missions. Engineers noted how the blizzard had masked visible signatures while simultaneously reducing infrared contrast, forcing reliance on inertial platforms and laser ring gyroscopes that never once deviated beyond their narrow error margins. The data confirmed what planners had theorized for months, that coordinated electronic obscuration combined with weather alignment could nullify even layered Russian air defense systems. The decoy wave had not merely absorbed missiles. It had manipulated engagement priorities, convincing automated logic trees to exhaust the very resources needed to stop the main attack. Every second from 3:10 a.m. to 3:17 a.m. had been structured to exploit those tendencies. Russian response teams deployed to the darkened factory with difficulty. Roads leading toward the complex were partially blocked by snowdrifts, and emergency lighting remained offline after the substation failure. Fire crews attempting to approach the wrecked press hall found molten metal cooling in uneven sheets that still radiated heat hours after the detonations. Inside the scorched chamber, columns bowed like softened rails, and fragments of the hydraulic cylinder lay fused into warped plates that had once been precision-machined surfaces. The air held the sharp scent of burned lubricant and vaporized steel, marking the boundary between what had stood and what had collapsed. Technicians arriving at dawn realized quickly that no salvage protocol would restore the presses to function. Even disassembly for transport was impossible. The machines had effectively melted into immovable masses bound to the factory floor. As official assessments trickled upward, Russian industrial planners confronted grim mathematics. Replacing a 25,000-ton hydraulic press was not simply a matter of funding, but of global capability. Only a handful of facilities worldwide could produce equipment of similar scale, and none would risk violating sanctions to ship a replacement. Even if clandestine channels were attempted, fabrication and transport would require years, not months, leaving the tank program without its core machinery. Welding turret rings from segmented components introduced structural weaknesses that ballistics experts had spent decades trying to eliminate. Tanks assembled with such compromises would not survive impacts that their predecessors endured, reducing battlefield survivability at a time when losses were already unsustainable. Supply officers understood the cascade immediately. Delays in the turret production meant idle assembly lines, bottlenecked drivetrain suppliers, and overstocked inventory with no final platform to receive it. Further complications emerged across the broader logistical network. Rail shipments carrying engines toward Nizhny Tagil were halted and redirected, causing congestion at hubs that had not been designed for extended storage. Workers at satellite facilities found themselves processing components for tanks that no longer had completion timelines, creating mismatches between labor, output, and strategic demand. Fuel allocations, once earmarked for transporting finished armor, were reassigned to other sectors, straining distribution patterns already disrupted by earlier strikes. The attack's impact propagated like a shockwave through spreadsheets and procurement systems, leaving officers scrambling to reassign budgets while acknowledging that no short-term solution existed. The shutdown of Uralvagonzavod was not merely a local failure. It represented a structural fracture in a defense ecosystem dependent on synchronized flow.
According to preliminary data, this morning a truck exploded on the road section of the Crimea Bridge from the side of the Taman Peninsula.
Russia's investigative committee says the blast was caused by a truck bomb and has identified the truck's owner as a resident of the city of Krasnodar.
At 4:14 local time on June 24th, 2025, a Russian Pantsir S-1 convoy rolled toward the Azovka Bridge, believing it was entering safe rear territory, not a prepared killing ground. The column carried firepower that normally travels under layered protection, not stretched across a single steel span above a narrow valley. For the crews inside the vehicles, this was a routine pre-dawn redeployment, another movement order on a crowded war map. For Ukrainian planners, however, those coordinates had been highlighted for weeks. They knew that within the hour, a decision taken in Moscow would align metal, explosives, and weak concrete in a way that could not be undone. The story did not begin on the bridge. It began in quiet back rooms where Ukrainian negotiators pushed a civilian-focused proposal that sounded almost boring on paper, a controlled humanitarian corridor across a 1.6-mile inland route that snaked through the hills toward Kherson. Officially, it was about food, medicine, and evacuees. Unofficially, it was a test of Russian intent and a way to measure how much Moscow valued this crossing. When the Kremlin rejected the accord, not gradually, but with an explicit personal refusal from the top, Ukrainian intelligence analysts understood the signal. If Russia would not use Azovka as a pressure valve, it would probably use it as a spearhead. Azovka Bridge itself was never meant to carry the weight of strategy. Built as a quiet inland artery, it stretched over a narrow valley with welded spans and concrete piers that engineers once considered adequate for mixed civilian traffic. Over time, maintenance delays and heavier military loads left scars that only specialists noticed. Span 145, a central segment above the deepest part of the ravine, had developed micro-fractures around an aging support bearing. For Ukraine, that span became an opportunity. Structural reports, satellite imagery, and seismic readings fed simulations that asked a simple question: how much force would it take to turn this crossing from asset into liability? The answer arrived from Moscow in the form of an order signed hours before sunrise. Instead of allowing neutral relief convoys, Russia pushed a 22-vehicle Pantsir S-1 column into the very corridor Ukraine had already marked as fragile. 6 launchers, 4 radar-controlled vehicles, 2 mobile command trucks, and 10 ammunition carriers loaded with roughly 14,057 E-6 missiles were told to move south and prepare the skies for a new thrust toward Kherson. On paper, this looked like a mobile air defense spearhead, worth hundreds of millions of dollars in equipment. In practice, it formed a single line of explosives and electronics, heading straight for the weakest span. Ukrainian planners had already reserved their answer. In a forward operations room, officers from the Air Force and military intelligence studied a digital model of the valley, tracing approach paths that threaded between Russian radar lobes like a needle through cloth. The platform of choice was the F-16 Block 50, a multi-role fighter able to carry precision glide munitions while staying low over terrain. Each jet would lift with a pair of bombs weighing roughly 250 kilograms apiece. weapons that could glide many kilometers before diving onto coordinates with meter-level accuracy. The objective was not only to destroy vehicles, but to drive force directly into the stress lines of span 145. By 4:10 a.m., the first decision that mattered was already fixed. Humanitarian traffic would not cross Azovka. Combat vehicles would. 24 minutes later, at roughly 4:32, the Panzer column rolled onto the approach road, engines droning at convoy speed while drivers scanned for roadside threats, not for danger from the sky. The crews believed they sat deep enough inside friendly lines to be untouchable. Their radars remained in transit mode, antennas folded or set to passive, conserving power and revealing little. To them, this was a safe inland bridge with no coastline, no obvious enemy firing positions, just layered hills and a steel ribbon arcing across a sleeping valley. That same valley looked very different through Ukrainian eyes. Long before the first vehicle touched the span, surveillance assets had mapped every contour, every heat source, every echo that mattered. When the 22-vehicle line began to stretch across the bridge deck, analysts in Kiev watched icons slide into a single choke point and marked the moment as irreversible exposure. Around 4:47, clearance moved through encrypted channels to the forward fighter detachment. Minutes later, 2 F-16s left their shelter, climbed just high enough to clear terrain, then dropped back into the folds of the landscape, throttles at military power, radar sets quiet, closing on Azovka under the cover of the hills. At 4:55 a.m., the lead fighter eased upward just enough for its sensors to gain visual confirmation on the target area. Below, the entire Russian formation stretched bumper to bumper across the bridge, each vehicle positioned with mathematical precision for a strike they could not see coming. The pilot watched the geometry stabilize, letting the aircraft's targeting computer convert bridge coordinates, vehicle spacing, and glide angle into a firing solution. When the authorization indicator turned green, the 2 GBU-39 bombs detached from their pylons, their wings deploying instantly as they dove toward the steel span, with guidance algorithms measuring distance in inches rather than meters. Above the valley, the fighters banked away, engines staying below afterburner to avoid generating signatures that surviving sensors might detect. The first bomb struck the nearest radar control vehicle, its warhead punching through metal plating before igniting the equipment inside. The explosion sprayed fragments outward, shredding antenna arrays and throwing shards over the guardrail. Helmets and panels briefly appeared as heat spots on infrared before vanishing into the rising blast cloud. The second bomb descended toward an ammunition carrier, a truck loaded with thousands of missiles whose propellant mass turned the entire rear of the convoy into a volatile chain waiting for a spark. When the warhead triggered, the delayed reaction lasted only a heartbeat. Then the cargo ignited, sending a white-hot plume along the deck that tore through the formation like a shockwave. Within seconds, canisters ruptured in rapid succession. Fuel tanks ignited as temperatures surged past thresholds that military vehicles were never designed to withstand. Infrared sensors recorded the blast column rising more than 200 feet, bright enough to overload some of the receiving equipment. The shockwave rolled into the hillsides, cracking glass in a village nearly 2 kilometers away. On the bridge, the 22-vehicle formation turned into a burning chain of debris as flames spilled across the asphalt surface. Vehicle frames bent and collapsed as heat exceeded temperatures known to warp structural steel. Around 4:57, the bridge itself began to react. No longer a stable platform, but a structure absorbing force it could not redistribute. Minutes later, the consequences began reaching Russian command posts. Around 5:02 a.m., fragmented reports indicated a catastrophic loss, with thermal readings near the bridge still above 600 degrees Celsius. Drones dispatched for assessment disappeared from feeds as residual explosions from cooking off missiles destroyed their optics. Attempts to move ground teams closer were delayed by intense heat and continuing detonations every dozen or so seconds. Operators initially suspected sabotage or guided artillery. Only later did satellite data clarify the pattern. Two precise impact craters, marking the signatures of F-16 delivered glide munitions. When analysts calculated the equipment lost, they faced a total write-off of mobile air defense assets valued at well over $230 million. The loss reshaped regional defense planning instantly. With roughly 11% of their mobile interceptors gone in one event, Russian commanders halted preparations for the planned push toward Kherson. Aircraft operating within a 150-kilometer radius were grounded under emergency protocols. Air defense coverage collapsed into temporary blind spots, forcing units to reposition and accept delays. At the same time, Ukrainian pilots completed the second half of their mission, withdrawing along low-altitude corridors, while Russian radar networks attempted to recover from the destruction of multiple mobile units. 3 of the 6 radar trucks had been incinerated outright. 2 were split by the blast. 1 had been thrown several hundred meters downrange and left unrecognizable. Ukrainian signals teams capitalized on the confusion, inserting decoy transmissions and false radar echoes into channels that Russian operators were trying to recover. For several minutes, Russian screens displayed conflicting data streams filled with ghost signatures that drew attention away from the retreating fighters. By 5:06 a.m., both jets crossed back into secure airspace, the mission log showing a total duration of 29 minutes from launch to touchdown. Analysts reviewing the strike later confirmed that the bombs impacted within less than a meter of their designated aim points, a level of accuracy that reflected coordination between intelligence, pilots, and surveillance teams monitoring every variable leading up to the strike. Within hours, Ukrainian forces launched coordinated FP-5 drone attacks that targeted exposed logistics vehicles and secondary command shelters. 9 supply trucks and 2 mobile command sites were destroyed in a series of strikes made possible by the absence of air defense units that had been eliminated on the bridge. Supply routes that once moved east to west now rerouted nearly 85 kilometers to avoid gaps in coverage, adding transit delays that stretched to 14 hours in some cases. Reports from frontline battalions indicated that daily resupply fell to as low as 40% of normal levels, slowing operations and forcing planners to reconsider timetables across the region. At mid-morning, international monitoring stations confirmed what Ukrainian analysts had already concluded. The blast from Azovka Bridge registered across a radius of more than 92 kilometers, placing it among the most significant non-nuclear detonations recorded that year. Satellite sensors captured thermal spikes, airborne particulates, and shock patterns that aligned with a cascading series of munitions ignitions rather than a single detonation. Analysts reviewing the data noted that by concentrating such a large volume of explosives on a structurally vulnerable span, Russian command had unintentionally created the conditions for a catastrophic chain reaction. This concentration amplified the effect of Ukraine's precision strike far beyond the destructive potential of the bombs alone, functioning as an explosive multiplier that no defensive doctrine could offset once ignition occurred. Across Russian channels, the internal reaction followed a predictable rhythm. Early transmissions included speculation about sabotage or the use of an unfamiliar long-range weapon. However, as overhead imagery arrived, the patterns became unmistakable. 2 aligned impact zones on the bridge deck matched the profile of glide munitions launched from low-flying fighters. Damage to the convoy displayed a sequence consistent with a chain reaction beginning at an ammunition carrier. Thermal signatures from the aftermath showed repeated bursts linked to missile propellant cooking off under sustained heat. As these findings spread, the operational consequences grew clearer. An air defense formation designed to shield southern ground forces had been reduced to scorched fragments in seconds. And with it, an entire operational plan collapsed. Russian commanders in the region confronted immediate constraints. Units positioned near the Kherson axis lacked the air defense coverage that allowed them to move with confidence in areas vulnerable to drones and low-flying aircraft. As a result, formations were ordered to halt or slow their advance until temporary replacements could be arranged. Logistics crews found themselves restricted to daylight movements along altered supply routes, reducing throughput and increasing exposure. Communications teams attempted to re-establish coherent radar coverage but faced the loss of critical nodes, each one requiring specialized equipment and trained operators. In the hours that followed, priority lists shifted from offensive momentum to damage control, a transition that reverberated through planning cells and field commanders alike. For Ukrainian intelligence, the operation provided a wealth of data that extended beyond immediate tactical success. Analysis teams examined the bridge collapse frame by frame, comparing heat maps and deformation patterns to pre-strike models. The correlation between explosive force and structural failure confirmed assessments that Span 145 represented a critical weakness. The manner in which the deck folded and separated exposed long-standing maintenance deficiencies. Even without the chain reaction, the span might have failed under a smaller blast if precisely placed. This validation informed future planning discussions that focused on identifying similar vulnerabilities along key military routes across occupied territory, marking them for potential interdiction should opportunities arise. The effects on Russian logistics manifested rapidly. Units relying on Azovka Bridge as part of their supply chain faced delays that rippled through their schedules. Fuel deliveries arrived late, ammunition movement slowed. Rerouted convoys traveled longer distances on roads that were not designed for heavy traffic, creating bottlenecks that forced some groups to wait for hours before passing through narrow choke points. Reports from the field described shortages of spare parts for armored vehicles, reduced availability of medical supplies, and the need for improvised fuel distribution using smaller trucks that took additional trips to meet demand. Although no single shortage threatened collapse on its own, together they increased pressure on units already balancing complex operational requirements. In Moscow, briefings presented an unwelcome picture. The loss of hundreds of millions of dollars in air defense equipment, the destruction of a critical bridge, and the subsequent disruptions placed planners in a difficult position. Rebuilding Azovka would require specialized engineering brigades, protected work zones, and a sustained flow of materials that could themselves become targets. Until reconstruction progressed, forces in the sector operated with reduced flexibility. Decision-makers faced a reality in which a single strike delivered by 2 aircraft had undone months of logistical preparation and forced revisions to timetables that had previously appeared stable. The incident served as an example of how precision, timing, and intelligence could offset numerical and material advantages. Even as reconstruction planning began, Ukrainian analysts continued reviewing communications intercepts and movement data to assess the longer-term consequences of the strike. Shifts in Russian redeployment patterns suggested that commanders sought to compensate for their reduced air defense presence by dispersing assets more widely than before. This dispersion lowered the effectiveness of integrated coverage that previously allowed layered protection. In addition, the need to pull units from secondary sectors to reinforce vulnerable points introduced imbalances that Ukrainian planners watched closely. Each change in the defensive grid created openings or increased stress on adjacent sectors. These adjustments carried risks that could influence future operations across the southern theater. At number 4, we have a very precise operation on Putin and his $90 million nuclear wings. Then the Tupolev Tu-95 factory gets destroyed. Let's watch. At 5:01 in the morning on an icy February night in 2025, 20 Ukrainian strike drones lifted off from a concealed strip of coastline facing the Sea of Azov. The air temperature hovered around 23 degrees Fahrenheit, cold enough to numb fingers in minutes, and sap battery performance by a brutal margin. On the Russian side of the water, lights still glowed in apartment blocks around Taganrog, where shift workers on the night line at the Beriev aircraft plant had no idea that in less than 15 minutes, their hangars would become the brightest objects in the entire region. The drones were not imposing machines. Each weighed roughly 5 pounds, small enough for a single operator to carry 2 in rugged cases. Their carbon frames were closer to racing quadcopters than to anything that appeared in official military brochures. What distinguished them was not size, but software. Their flight controllers ran custom code trained on thousands of hours of bird flight footage, giving each drone a slightly irregular, organic wobble. To ground radar and optical trackers that relied on smooth trajectories, The swarm did not look like 20 distinct aircraft. It looked like one indistinct anomaly. On a folding table inside a dim Ukrainian command shelter, 3 operators watched the first telemetry traces scroll across ruggedized tablets. The drones were climbing through a layer of coastal haze at a shallow angle, riding low over the water to avoid line of sight from Russian radar posts near the border. A mesh network linked them together, each airframe acting as both sensor and relay, sharing position data and signal paths in microsecond cycles. If one node dropped out, routing shifted automatically, like a flock tightening up when a bird fell away. The target lay roughly 50 miles from the launch point on the northeastern shore of the Sea of Azov. Taganrog's Beriev plant was more than just another industrial facility. Inside its long concrete halls and corrugated metal hangars, technicians maintained and modernized Russia's Tu-295 strategic bombers. Those 4-engined turboprop aircraft, with their swept wings and iconic contra-rotating propellers, formed a key part of Moscow's long-range strike capability. From runways deep inside Russia, they launched Kuk-55 cruise missiles at cities and infrastructure across Ukraine. In Ukrainian planning cells, a single phrase kept appearing on whiteboards and encrypted chats, expressed in different ways, but always carrying the same logic. If you cannot intercept every cruise missile in the air, you make it harder for the bombers to take off at all. The Beriev plant was not just a repair shop, it was a bottleneck. Mk-12 turboprop engines were not easily replaced, and the specialized tooling needed to handle them was scattered across only a handful of sites. Damage there would not be measured in days of downtime, but in seasons. By 5:03 in the morning, the swarm had already crossed the invisible maritime extension of the international border. Instead of flying a straight line, the drones followed a path pre-computed to weave along low-lying terrain and shallow folds in the coastline elevation. Digital elevation models loaded into their onboard memory allowed them to dip behind ridges, skim reservoir banks, and hug the darker gaps between isolated farmsteads. From the perspective of a Russian radar operator watching a glowing screen in a warm cabin, nothing unusual drifted into the main search volume. The first major defensive ring around Taganrog did not consist of fences or guard towers. It was electromagnetic. Russia had positioned S-400 batteries and Panzer S-1 gun and missile systems to cover the approaches to military infrastructure across the region. Their search radars were tuned for cruise missiles, manned aircraft, and larger drones. None of them were designed to treat a cluster of 5-pound electric quadcopters as a primary threat. When the swarm's combined radar signature finally nudged above the background clutter, automated classification flagged it as a single small object, most likely a slow-moving missile or stray weather return. Inside one S-400 command module, a duty officer acknowledged a tentative contact reported by a subordinate radar station. The trace was low, slow, and intermittent, appearing and fading as the cluster dipped behind terrain. Engagement priorities were already stacked with higher altitude traffic near other sectors. Doctrine dictated that such marginal contacts should be monitored rather than engaged, especially when ammunition stocks for ready-to-fire missiles were not easily replenished. The officer tagged the track with a generic label and moved his attention back to other blips, unaware that each delay of a few seconds gave the swarm more room to advance. The drones themselves were not ignorant of the attention. Embedded in each flight controller was an electronic support package that sampled the radio spectrum many times per second. Spikes in known radar bands triggered micro-adjustments in altitude and spacing. When the swarm software detected a rise in emissions consistent with search radars to the north, the front rank of drones dipped 30 feet lower, dragging their companions with them in a graceful bird-like roll. To an external sensor, the already faint ghost of a target smeared even further into noise. Communications followed similar principles. Instead of locking onto a single control frequency, the swarm used artificial intelligence-driven frequency hopping, shifting among dozens of channels in patterns derived from pseudo-random sequences and real-time interference maps. At any given moment, some drones listened on one band, others on another, passing packets through the mesh like whispered messages in a crowded room. To a system like the Krashika 4 electronic warfare complex deployed near key air bases, the aggregate signature looked like a glitch rather than a clear pattern. Attempts to blanket jam one band simply caused the swarm's algorithms to shift emphasis to cleaner slices of spectrum. The Sea of Azov's surface beneath them, dark and lightly ruffled by winter wind, provided one more layer of protection. Cold water held a narrow temperature range, while the low-flying drones shed just enough heat to blur into background when seen through medium-resolution thermal sensors. Only when they crossed the shoreline and began to sweep over drier land did the contrast sharpen. Farm buildings, transformer stations, and exhaust from distant factories painted the infrared landscape in brighter strokes. But by then, the distance to Taganrog had dropped to less than 20 miles, and reaction windows were narrowing fast. By 5:04 in the morning, the swarm had broken into smaller elements. The lead group of 8 drones took on the role of pathfinders, spreading out into a loose arc that extended across several city blocks. They flew just high enough to clear power lines and rooftop structures, their cameras streaming compressed infrared and low-light imagery back to the operators. A second cluster lagged behind as a reserve, ready to substitute for losses or exploit gaps. The remaining drones tightened up into what looked on radar like the body of a single object, using the Pathfinder's mesh links as a communications backbone. Above them, an aging Russian surveillance radar swept through its cycle again and logged a slightly stronger return, now plotted just kilometers from the Beriev perimeter. Correlation software attempted to reconcile the track with flight plans and known patrol routes. No scheduled Russian aircraft matched the profile. Someone in the command chain marked it as a probable unmanned object and forwarded a recommendation for engagement to a nearby Panzer S-1 battery. The self-propelled gun and missile systems operator acknowledged the order and began to slew his sensors toward the sector, expecting to see a clear cruise missile silhouette. Instead, the optical sight returned only faint points of moving light against the city's thermal clutter. At the same moment, the Krzyzewka 4 complex ramped up its emissions, flooding a set of suspected control frequencies with powerful interference. The beamform jamming was designed to blind reconnaissance drones and disrupt SATCOM links. The swarm's response unfolded in milliseconds. Signal strength indicators inside each drone flashed alerts, and the mesh network reoriented itself, shunting critical control packets away from the most heavily jammed bands. As a final layer, a subset of drones shifted into a semi-autonomous mode, relying more heavily on preloaded waypoints, terrain matching, and visual cues. If every external signal vanished, they would still continue toward the last known vector to Hangar 3. Inside the Ukrainian shelter, the operators monitored the last approach in near silence. A narrow status window showed battery levels dipping faster than ideal due to the cold, but still within expected tolerances. Speed indicators held steady around 40 miles per hour as the drones threaded through the industrial outskirts. Their internal gyros compensated for turbulence sweeping in from warehouses and rail lines. Despite the electronic interference, telemetry remained stable enough to maintain coordinated flight. The operators adjusted nothing beyond small course corrections. Most of the work was now in the drone's onboard logic. The frontmost drone reached the outer fence of the Beriev complex first. Its downward-facing sensor captured the grid of security lights, the long shadow cast by Hangar 3, and the faint glow of the motorized door partially raised for early shift maintenance crews. Through a mixture of routine and oversight, workers had begun preparing workspaces earlier than usual. The door's lower edge was already lifted enough for a person to duck under. For the swarm, that gap was a pathway. The software flagged the opening, and 2 drones peeled off to investigate, while others maintained spacing overhead. At 5:05 in the morning, the factory password vulnerability shaped the outcome. One drone hovered at a precise angle, broadcasting the unchanged maintenance code through a low-power transmitter. In a small control box mounted beside the door, a relay clicked. The motor engaged. The steel door lifted with a heavy, rhythmic clatter, rising just enough to expose more of the interior. The drone did not force access. It merely nudged an overlooked weakness that had been waiting for someone to exploit. As the gap widened, 4 drones darted forward in quick succession. Their silhouettes slipped past the threshold before the door reached its halfway point. Inside Hangar 3, fluorescent lights cast a pale glow on concrete floors and the curved forms of the 2 Tu-295 bombers under maintenance. Hydraulic jacks supported their wings at precise angles. Tool carts lined the aisles. A cluster of oxygen tanks stood near one aircraft's midsection. Pallets of training K-55 missiles, their solid propellant cores sealed in protective casings, were stacked along the far wall. Technicians elsewhere in the building were gathering equipment for the morning routine, unaware that the first drone had already glided above the wing of a bomber that had launched cruise missiles only weeks earlier. The drones carried shaped charge warheads designed to pierce metal rather than disperse fragments. Each warhead weighed just over 1 pound, optimized for focused energy rather than raw explosive volume. Fired directly against thin steel, an explosively formed jet reached temperatures high enough to perforate structural members or ignite sensitive stores. Against oxygen cylinders or aluminum wing sections filled with tens of thousands of gallons of JP-8 fuel, the effect would magnify. The operators watching from Ukraine saw the first drone's camera lock onto the reflective surface of an oxygen tank. No additional signals were required. The drone's autonomous routines understood the target profile. The hangar's automated suppression system hesitated. Sensors registered rising temperature, but metal surfaces distorted readings with streaks of reflected heat. Only when the flames reached a threshold near the ceiling did the system prepare to release suppressant. By then, the third drone had already targeted a cluster of K-55 training missiles. Though inert in terms of warheads, the solid propellant inside each casing was energetic enough to burn intensely once exposed. The shaped charge struck the nearest missile casing at an angle that ruptured its outer shell. Burning propellant spilled across the floor, accelerating the spread of fire toward tooling racks and engine stands. Outside, the drones that had not yet entered the hangar circled above the facility. Their thermal cameras showed the growing intensity of the fire inside. Secondary explosions from ruptured tanks, propellant spills, and engine compartments created rolling shockwaves that vented through the widening gaps in the roof. One drone attempted to descend for a final strike, but was consumed by heat rising from the opening. The remaining airborne units switched to surveillance mode, capturing the spread of fire along the hangar's interior framework. Through tendrils of smoke, the shape of one Tu-95 sagged as its wing collapsed, its aluminum structure losing rigidity under sustained heat. By 5:07 in the morning, the defensive systems around Taganrog recognized that something catastrophic was unfolding. Radar operators who had dismissed initial traces attempted to reacquire targets amid the thermal distortions rising from the burning hangar. The Panzer operator, seeing the plume from a distance, assumed incoming munitions or a fuel explosion. He fired 2 missiles toward the general area, but the drones had already fragmented into patterns too irregular for tracking. One missile detonated harmlessly in open air. The other veered off into the dark, unable to locate a stable reflection. The blackout of reliable sensor data prevented any coordinated response. In the Ukrainian command shelter, the operators watched the final telemetry streams blink out one by one as rising heat and structural collapse overwhelmed the drones still inside. The fire had grown into a self-sustaining event that no human intervention could reverse quickly. Flames raced along tool racks and across aluminum skin panels. Roof supports buckled, creating cascading failures that brought down large sections of overhead structure. By the time the last drone signal faded, Hangar 3 was in full structural failure, and the 2 strategic bombers inside were already beyond salvage. At 5:13 of the morning, the first exterior wall of Hangar 3 failed. The panel buckled outward as internal pressure exceeded its load tolerance, releasing a pulse of heat and smoke that rolled across the tarmac like a low, drifting cloud. Fire crews stationed on the far side of the complex scrambled to respond, but the intensity of the blaze forced them to keep distance. Burning JP-8 cascaded through openings in the structure, feeding a fire that brightened the pre-dawn horizon. Even from several blocks away, residents awakened by the blast saw an expanding glow above the industrial district and assumed a fuel depot had ignited. Inside the plant's operations center, supervisors attempted to coordinate a response while alarms blared across every console. The facility's internal cameras failed one after another as heat warped casings and melted cable insulation. Automated systems struggled to compensate for the loss of data, switching between partial sensor feeds and fallback modes. Emergency protocols directed teams to isolate power circuits, but rapid-fire spread rendered the hangar unsafe for entry. With each passing minute, the temperature climbed, compromising additional structural members. Engineers monitoring temperature readouts realized that the roof would not hold. That failure came shortly after 5:15. A deep metallic groan echoed across the complex as remaining trusses twisted under load. When the roof collapsed, it did so in several sections at once, dropping tons of heated debris onto the burning air raft. The impact forced burning fuel outward in a bright surge that flashed through gaps in the walls. The resulting fireball rose higher than the plant's lighting towers, leaving a plume of black smoke suspended above the city. Local emergency dispatch centers fielded calls from residents across Taganrog, reporting explosions and flames near the airfield. Responders dispatched units, but warned crews to expect extreme hazards. By 5:20, the destruction inside Hangar 3 had progressed beyond containment. The NK-12 engine stands nearest the collapse zone toppled, spilling burning oil across the floor. Hydraulic reservoirs ignited. Composite insulation panels, once designed to withstand moderate heat, shriveled into brittle remains that crumbled under the weight of falling debris. The second Tu-295, positioned closer to the rear wall, lost structural integrity in its wing root, causing the wing to fold downward and fracture. With critical systems destroyed, both airframes were now unsalvageable fragments of aluminum, steel, and ruined machinery. The events of that February morning demonstrated that decisive outcomes can emerge not from large platforms or overwhelming firepower, but from precision, planning, and exploitation of the smallest vulnerabilities. As Taganrog's hangar smoldered into the afternoon, its collapsed walls and charred aircraft stood as evidence of a shifting landscape in which autonomy, adaptability, and modest resources could produce consequences once thought achievable only by large strike packages. At number 3, you will see Vladimir Putin's multi-million-dollar guest house obliterated by Ukrainian drones. Let's watch. At 19:30 Moscow time on the evening of September 21st, 2025, warm lights spill from a luxurious guest house in Crimea overlooking the Black Sea, and a private event for Russia's elite moves from toast to toast, as if the war is far away. The script frames the venue as more than a resort. The Forty Sanatorium, near the Foros Cliffs, sits beside state-owned dachas linked to security planning, the kind of place where comfort and command share the same corridors. Conversation and soft music hide that decisions made here ripple across ports and trenches, and the script signals this night will be measured by seconds, not speeches. That assumption is the opening weakness. Miles out on dark water, a low silhouette unmanned surface vessel slices through the swells with a fiberglass hull designed to slip through waves and keep its radar return faint. It is identified as a Magura Phi-5 drone boat, acting as a mothership rather than the main weapon. Inside its bay sit 6 OSA first-person view drones, compact and sortita, each built to sprint the last stretch. The boat's purpose is to bring them close without announcing its presence, turning distance into a false comfort. It stays far enough from shore to seem irrelevant, yet close enough that a minor course change becomes danger, with the sea surface acting as a mask for motion. The payload is described with clinical specificity. Each OSA drone carries a 1.5-pound shaped charge, intended to form a superheated jet of metal on detonation, concentrating force for penetration rather than blast. The script compares the effect to punching through concrete and steel as if they were paper, and later extends that threat to armored glass and vehicles. In this story, the warhead is not presented as a statistic, but as a promise, the kind of compact violence that makes defenders pay for every second of delay. The narration dwells on focus over spectacle, using the shaped charge detail to foreshadow how prestige architecture can fail when struck at the right point. The target selection is framed as strategic theater with practical consequences. The sanatorium is called a private playground for war criminals and planners, positioned near facilities associated with the Federal Security Service, where new waves of secret plans are imagined and refined. Striking it is not only about humiliation at a banquet table. It is tied to blinding the coastal network and protecting Ukraine's grain corridor, the export lane whose safety determines whether the economy breathes. By linking the venue to planning and surveillance, the story ties the strike to maritime security, implying that a blind coastline can widen the grain corridor. At 1931 local time, roughly 3 miles from the Crimean coast, the Magura slows to a crawl, and the bay doors open as if the sea itself is exhaling. One by one, 6 dark shapes slip into the Black Sea, and the mothership provides a final laser guidance lock, measured in 10 seconds before withdrawing into shadow. The handoff is described as parental, the larger craft leaving the mission to its children. And the timing becomes the tension. Seconds of guidance, minutes of flight, and a coastline packed with eyes. The mothership's retreat reads as confidence because the most dangerous leg begins near land, where humans and sensors overlap, and there is no reset button. The OSA drones accelerate to 60 miles per hour and skim low enough to taste salt spray, but they do not travel in a straight line. The tactic is named the Ghost Chain, credited to Ukrainian intelligence, and it is built on misdirection. The lead drone releases a cloud of aluminum chaff, described as 500 strips, turning the radar picture into a blizzard of false targets. Behind that electronic snowstorm, the remaining drones tuck in close, using the chaff as a moving shield while they press toward the cliffs. The chaff is cheap metal doing expensive work, and the chain metaphor matters because each drone's survival depends on the one ahead, like shared camouflage. The script then compresses the coastline into a knife edge of exposure. The drones hug the base of the Foros cliffs, flying in the radar shadow of rock, and briefly pop off for only a few seconds and only a few feet before dropping back into darkness. That rhythm creates the sense of a heartbeat. Reveal, vanish, reveal, vanish. Each burst timed to clear a patrol boat ahead, without inviting a sustained lock. The sequence connects geology to tactics, turning the cliff line into a stealth corridor that cannot be moved or jammed. Each brief pop above the cliff shadow is a calculated risk, because a sustained rise could invite small arms, thermal optics, or a lock from a nearby battery. At 1932 local time, the physical world pushes back. A strong wind gust hits the swarm and punishes drone number 3, described as the one with a corroded antenna, and a small targeting error becomes a stability crisis. The scene cuts far away to a concrete bunker deep beneath Odessa, where an operator watches his display flicker and fights the controls manually while flying blind behind chaff and interference. The mission scale collapses into his fingertips because one unstable drone threatens the timing that keeps the rest hidden. Distance does not reduce pressure, it sharpens it because the operator feels the wind only through telemetry, and one bad correction could expose the swarm. On the shoreline, the defenders are shown as alert individuals rather than faceless systems. A Russian Spetsnaz operator sweeps the cliffs through a high-end thermal scope, looking for a flicker of heat, and the moment his routine patrol finds something, the story pivots. At 1927 local time, his scope flares on a fast hot signature, and he raises a specialized drone gun that fires a focused beam of electromagnetic energy. The decoy drone's electronics are fried, it erupts in sparks, and it plunges into the sea as a clean, confident kill. The drone gun is presented as precise and modern, and the irony lands immediately. The one target he can see is the one Ukraine can afford to lose. That radioed victory becomes the trigger for a larger mistake. 30 seconds later, a radar screen at a Panzer S1 battery near Yalta lights up, but the operators do not interpret 5 small drones. They see a single massive signature, exactly what the chaff cloud was designed to create, and the system labels it enemy with the confidence of automation. A surface-to-air missile is launched at enormous cost, accelerating toward the cloud and smashing into aluminum strips that were never alive to begin with. The flash convinces the crew they scored a direct hit, while the real attackers remain untouched and closer. The story stresses the mismatch between screens and reality, showing how automated certainty can be weaponized when humans follow a false picture. While attention fixes on that phantom, the Magura V5 plays its last diversion offshore, now about 10 miles out. It begins broadcasting a fake electronic signature meant to mimic a much larger vessel. And on a Russian patrol boat's screen, a new priority target appears at the worst possible time. Patrols turn seaward, drawn away from the shoreline, clearing the final path for the real swarm moving under the cliffs. The script binds this to the wider sea picture, where commercial routes and military assumptions overlap, and one false blip can redraw a patrol pattern in minutes. The diversion layers with the grain theme, placing commercial silhouettes and military deception in the same water, where seeming matters as much as being. Then the alarm network escalates again. Sirens are described sounding across Sevastopol at 1928 local time, and an Su-30 fighter jet rockets into the night, its afterburners tearing light into the sky as it races to intercept. The script frames the jet as a Mach 1.9 Predator, built to kill anything that flies. Yet the drones deny it the fight it wants by splitting into multiple altitude profiles and pressing toward a no-fire zone near supposedly civilian dachas. The geometry becomes the weapon. Too many small threats, too close to sensitive space, too little time to sort them cleanly. It sets up the next dilemma. Near protected zones, defenders choose restraint or overreaction, and tension climbs. The Russian response shifts from speed to saturation as electronic warfare floods the air. A wide-area jamming blanket descends like an invisible storm, described as powerful enough to drown civilian radios and military links alike. In Odessa, operators watch control feeds fill with static, and for a moment the drones appear isolated, cut loose from human hands. The script leans into the pause, explaining that this is the instant many defenses expect machines to fail. Instead, the OSA drones slide into autonomy, ignoring the noise and relying on internal gyroscopes and inertial systems that feel every turn and dip. Navigation becomes instinctual rather than communicative, and accuracy remains high enough to matter, reinforcing the recurring idea that physics is harder to silence than signals. The defenders add muscle to interference. Along the cliffs, Spetsnaz teams deploy kinetic nets and open fire with thermal-guided machine guns, their tracers stitching the darkness where heat signatures flicker. One OSA drone disappears in a brief flower of fire against the rock face, reducing the swarm to 4. The narration does not mourn the loss, it counts it. 1 down, 4 to go, with time compressing into a countdown that matters more than totals. Each surviving drone now carries more responsibility because the formation's geometry must hold even as numbers shrink, and the cliff shadow that protects them also limits their room to maneuver. Back in the bunker beneath Odessa, the operator wipes sweat from his brow as a critical number flashes on his display. 20 seconds to target is not presented as distance but as pressure, because at this point, every correction risks exposure. The script contrasts predators, describing Russia as a cheetah built for speed, and Ukraine as a fox built for angles and patience, framing the engagement as hide and seek, where agility beats raw chase. That metaphor matters because it reframes loss tolerance. A fox expects attrition and plans for it, while a cheetah expects a clean sprint and struggles when the quarry fragments. As the sky fills with money, the Russian defense network escalates again. Millions of dollars of ammunition are hurled upward as batteries and crews hunt for small shapes that refuse to behave like aircraft. At 1929 local time, one OSA drone changes its electronic signature completely. Instead of broadcasting threat, it screams the identification code of a civilian passenger aircraft and plots a path that appears to intersect a local school. The bluff is framed as digital theater rather than recklessness, a calculated manipulation of rules of engagement designed to freeze a hierarchy that cannot afford the wrong headline. The effect ripples instantly. On radar screens in Sevastopol, confusion spreads as orders conflict and permissions collide. Systems from the long-range S-400 batteries to individual soldiers hesitate for seconds that feel like minutes, all eyes locked on a phantom civilian track that demands caution. Those seconds are the currency Ukraine needs. While commanders argue, the 4 real attack drones slip through the radar shadow of the cliffs and emerge undetected with a clean line of sight to the 40 sanatorium. The script treats this as the fulcrum moment, where attention becomes the scarce resource, and misallocated attention opens the gate wider than force ever could. Offshore, the Magura Bef-5 has not left the story. Now roughly 20 meters from the coast and tucked into the shadow of a grain freighter, it performs its final act. A single tight beam laser pulse arcs across the water. The image is intimate, almost tender. A machine reaching out to steady another at the last moment. The freighter's presence ties commerce to conflict again, reminding the viewer that civilian silhouettes are both shield and stake in this environment. In the bunker, 4 green boxes lock onto the thermal signature of the main hall. The operator's voice is described as calm and cold as he announces that the trap is sprung. The clock hits 19:30 local time, and the bluff collapses as Russian commanders realize the deception. Rage replaces hesitation, and the Pantsir systems come fully alive. 30mm cannons open up, spitting a wall of steel at thousands of rounds per minute, filling the air with explosive shells designed to shred aircraft. The script emphasizes the density of fire to heighten contrast with what follows, because evasion is not the chosen response. The 4 OSA drones do not scatter. They converge. The narration lingers on that choice, framing it as a refusal to play the defender's game. They dive through the curtain of fire in formation, lining up on a single point of attack, the main hall of the sanatorium. One drone, the one whose targeting was repaired at the last second, takes the lead and holds an unshakable lock on the heat bloom of a crowded banquet hall. The convergence transforms chaos into inevitability, and the audience is positioned to understand that the last defense has already failed, even as it grows louder. At the command, described as a baton pass rather than a trigger pull, the payloads detach. The drones themselves are demoted to couriers as 4 1.5-pound shaped charges snap free, fins deploying as they begin a terminal dive at speeds exceeding 200 miles per hour. The drones bank hard and turn back toward the sea, toward the Magura, waiting in shipping lanes, their role complete. The separation matters because it undercuts the defender's last hope. Killing the carrier no longer kills the weapon, and the focus shifts to physics and timing rather than electronics. Inside the sanatorium, the party becomes a study in disbelief. The roar of Panzer cannons drowns conversation as a Spetsnaz commander shouts conflicting orders, and a high-ranking guest drops a glass that shatters on marble. The script emphasizes the gap between jamming confidence and kinetic reality, noting that the warheads care nothing for interference because they carry no electronics to fry. They are guided by momentum and geometry, indifferent to noise. That indifference is the true antagonist here, because it cannot be negotiated with or persuaded to stop. The first warhead strikes the glass roof of the main hall, and the narration slows to describe mechanics. Armored glass vaporizes rather than shatters under hundreds of foot-pounds of force, and the shaped charge focuses its energy into a jet of molten metal at thousands of degrees Fahrenheit. The jet punches through marble as if it were cardboard, a finger of man-made lightning, aimed precisely where heat was densest. The language is technical but visual, turning the impact into a process rather than a flash. The final charge strikes the special event hall dead center, reducing the meeting table and the plans upon it to ash. The script adds that the electromagnetic pulse from the blasts fries local radar systems, blinding a section of the Crimean coast in one stroke, tying destruction inside to blindness outside. Russian response units arrive into confusion rather than control. Fire crews fight secondary blazes fed by ruptured gas lines, while security teams secure corridors that no longer connect. Communications degrade as local radar nodes remain blind, forcing reliance on distant sensors with delayed feeds. Naval patrols pull back instinctively, unwilling to linger near a coast that just proved hostile to layered defenses. The withdrawal is not announced, but it is visible in gaps on maritime tracking display. The Black Sea Fleet shifts posture, conceding space without admitting why. That space matters. Within hours, Ukrainian planners register the effect not in wreckage, but in movement. Commercial traffic adjusts routes as warnings ripple outward, and the safe grain corridor quietly widens as patrol density thins. The script frames this as leverage earned by precision rather than mass, where a single strike reshapes behavior. The sea becomes less contested, not because ships were sunk, but because confidence was. Insurance algorithms and shipping captains respond to risk signals faster than statements, and the absence of patrols speaks louder than communiques. Inside Russia's command chain, the damage compounds. Plans discussed at the sanatorium vanish with the hall that held them, and redundancy proves thinner than expected. The loss is not just paper and screens, but time, as parallel teams attempt to reconstruct context from fragments. The narrative emphasizes that secrecy collapses under pressure. When a node is removed, the network reveals how much depended on it. For coastal operations, that dependency translates into caution, delays, and orders rewritten midstream. The operators who launched the strike do not celebrate at the site. In Odessa, deep underground, the Ukrainian team watches satellite feeds confirm what sensors already told them. The camera lingers on faces marked by fatigue rather than triumph. They track secondary fires, count surviving drones returning to sea, and log the moments when radar coverage drops offline. The emphasis is procedural. Success is measured, recorded, and banked for the next decision. Emotion stays contained, because the window that opened may close if mishandled. The ghost chain tactic earns its reputation in debriefs. Analysts note how misdirection outpaced suppression, how chaff and shadows forced expensive systems to fight illusions. The lesson is not novelty, but sequencing. Each layer forced a choice, and each choice cost seconds. Those seconds compounded into a corridor of opportunity that no single defense could close. The script reinforces that this was not improvisation but design, a chain whose strength lay in the order of its links. Russian defenses adapt quickly, but adaptation admits vulnerability. New rules appear around no-fire zones, electronic identification, and patrol geometry. Each rule reduces freedom of action, trading flexibility for safety. The script frames this as a tax imposed by the strike, paid daily in caution. Jets still launch, batteries still scan, but commanders now ask different questions before authorizing fire, aware that hesitation can be weaponized against them. On the water, the Magurov 5 slips back into anonymity, its role complete. It blends with traffic patterns that never stopped moving. The narrative highlights restraint. No pursuit, no chase, no signature to follow. Survival is treated as success equal to impact, because a system that returns can be used again. The sea absorbs the evidence, leaving investigators with fragments and timing rather than a target. The damaged coastline forces a recalculation of air defense posture. Batteries repositioned to cover blind arcs, thinning coverage elsewhere. The script underscores the zero-sum nature of coverage. Protecting one sector exposes another. For Ukraine, that redistribution is the outcome, not the ruin itself. The map matters more than the photograph, and the map now shows wider lanes where none existed the night before. As hours pass, the narrative tightens around cause and effect. A guest house strike becomes a maritime adjustment, which becomes an economic shift. The chain is traced backward to choices made in seconds by operators trusting instruments and training. At number 2, we will see Ukraine erasing Putin's Kremlin command network in minutes. Let's watch. 3:15 a.m., November 27th, 2025. The Shatura thermal power station is supposed to be breathing steady heat into the veins of the Kremlin's command grid, but instead, The 1,500-megawatt heart of Moscow is liquefying, steel and copper collapsing into glowing slag. Across the capital, lights flicker out, and more than 33,000 homes fall into freezing darkness, while the air outside gnaws at 0 degrees Fahrenheit. Hours earlier, Vladimir Putin dismissed peace talks with a smirk and sent missiles toward Kiev. He assumed the night belonged to him. He was wrong. Rewind 28 minutes. 2:47 a.m., 75 miles southwest of Moscow. 30 Ukrainian AN-196 Labuti drones move through the frozen sky so quietly that even the wind struggles to hear them. They have already crossed more than 200 miles at low altitude, hugging the terrain between 100 and 300 feet. Too low for long-range radar to track reliably, yet just high enough to avoid the Russian forest canopy. They have spent 6 hours flying a razor's edge between physics and survival. Now the marathon flight is ending, and the sprint begins. Distance to target, 5 miles. Time remaining, 94 seconds. Inside a reinforced bunker west of Kiev, encrypted monitors display their objective. 3 towering step-up transformers, each weighing more than 10 tons, and loaded with roughly 40,000 liters of superheated dielectric oil. Damaging one transformer is an annoyance. Destroying all 3 triggers a cascading overload that will force the Kremlin's command grid into respiratory failure for at least 72 hours. While Putin mocked mediators on live television, his Tu-295 bombers launched Kinzhal missiles toward Ukrainian neighborhoods. He intended to freeze families in the dark. He never imagined a counterstrike arriving this fast, this quiet, and this deep. Between the drones and the power station stands one of the densest air defense networks on Earth. On tactical screens, the map is saturated red, rings of Panzer S-1 and S-400 batteries layered over each other. Russian officers wait comfortably for targets to appear at standard cruise altitude, focusing upward, convinced nothing could survive their radar net. They do not realize the strike package is preparing to drop into a narrow southern valley and skim the ground at 20 feet, lower than the roofline of a 2-story house. It is a place where radar energy fractures against the terrain and where even automated tracking falters. 3:13 a.m. The first 10 Labuti drones receive a single encrypted command that overrides every survival subroutine. All engines surge to full power. Noses pitch upward 20 degrees. The drones burst from the valley floor straight into the engagement envelope at 12,000 feet. Inside an S-400 Triumph battery 10 miles north of the power station, the slow night rhythm breaks instantly. The 92N6E Gravestone radar, capable of tracking 100 airborne threats at once, now shows 10 large, slow-moving returns. The senior lieutenant sees what he expects to see: cruise drones on an attack path. He orders tracking and authorization to fire. The S-400 answers without hesitation. 448 N6DM interceptors erupt vertically from their launch tubes, gas generators tossing each 2-ton missile 10 meters upward before the solid motors ignite. Designed to chase fighter jets and ballistic threats, these missiles leap to Mach 6, more than 4,500 miles per hour, within seconds. Against fiberglass drones crawling at 90 knots, ferrying them is like swatting mosquitoes with freight locomotives. High above the valley, the decoys continue their mechanical climb. They carry no flares, no jammers, and no evasive logic. Their only purpose is to exist just long enough to die. 9 seconds after launch, the lead interceptor's radar seeker pinpoints the first drone, calculates the intercept, and detonates its 180-kilogram warhead. The explosion unravels the small aircraft instantly, dissolving it into superheated fragments that vanish into the night. The remaining missiles follow with equal precision. White flashes bloom and fade over Shatura as 10 fireballs fall toward the frozen ground. In the S-400 cabin, the crew erupts in celebration. The senior lieutenant reports to Moscow that the target group is eliminated, airspace cleared, interception flawless. He believes he has won. He does not realize he has just spent roughly $14 million in premium missile to destroy barely $200,000 worth of decoys. Worse, his launchers now sit empty, and the real threat is only seconds behind. 40 seconds later, the smile fades from the operator's face. New radar contacts appear, low altitude, faster, incoming from a different vector. 10 new signatures approach at roughly 3,000 feet, 8 miles out. This fight is no longer in the S-400 envelope. Now the battle belongs to the Tor M2 systems hidden among the birch trees around the power station. 3 Tor vehicles awaken, their tracking radars sweeping in tight arcs. Designed to intercept supersonic aircraft and cruise missiles, their fire control computers analyze the incoming drones in under 1 second. Cold launch tubes snap open. Missiles are ejected upward by compressed gas, tossed 10 meters into the air before their thrusters ignite and hurl them horizontally toward the Ukrainians. 7 drones vanish instantly, shredded by fragmentation warheads that explode 10 meters ahead of their targets. Propellers and control surfaces disintegrate under clouds of high-speed metal, but 3 drones survive, slipping under the Tor's minimum engagement distance. Now, the fight shifts again to the Panzer S-1 cruise. Inside the armored cabin, a gunner sweats under the red glow of targeting monitors. He sees 3 drones racing toward him. At 100 knots, he switches from missiles to the twin 30mm autocannons. Trigger depressed, the cannons unleash a storm, more than 5,000 rounds per minute, filling the air with streaks of burning metal. The first drone flies directly into the barrage, dissolving instantly. The second and third Jink left, but the optical tracker stays glued to them. Fire walks across the sky, sawing both drones apart. The Russian commander leans back, breathing hard. The S-400 is empty. The Tors are reloading. The Panzer's barrels glow faint red. He radios the Kremlin grid, reporting that all threats have been neutralized and that reloading will require 3 minutes. He believes the danger has passed. He does not understand that 3 minutes is enough time to change the fate of a capital. The moment the Russian commander finishes speaking, motion floods the radar scopes. From the same southern valley, the first drones used as cover, 10 remaining Labuti strike drones surge upward in a synchronized pop-up maneuver. They climb from 20 feet to 800 feet in seconds, but they do not attack. Instead, their payload bays open mid-air, releasing 2 objects each. These objects do not fall like bombs. They ignite. 20 modified first-person view quadcopters spring to life, racing drones built for violent acceleration and unpredictable trajectories, erupting outward like a swarm of angry hornets. The sky becomes a battlefield that Russian targeting computers were never designed to comprehend. These mini FPVs do not fly straight. They corkscrew, hover, dive vertically, or burst left and right in erratic spasms. To radars optimized to track smooth arcs, ballistic paths, and linear speeds, these shapes may as well be hallucinations. The algorithms choke. Reticles flicker across the screens without locking. Unstable contacts multiply. Is it a drone? Is it a bird? Why is it rolling over itself? Why is it drifting sideways? The software cannot answer any of it. The Panzer crews panic. Targets flood every display. Multiple, erratic, close. They open fire with their twin 30mm cannons, unleashing 6 torrents of high-explosive incendiary shells that tear bright lines across the sky. The Russian volume of fire is overwhelming, but the FPVs fight back with chaos, not strength. Still, chaos is not armor. Russian saturation fire begins to take victims. A Panzer on the left flank abandons the FPVs and locks onto a Labuti mothership that hesitates in its dive. A short burst of 30mm fire hits the wing root, tearing it in half and sending the drone down in a tumbling blaze. To the right, a TOR operator finishes reloading, slams the canister door shut, and launches a 9M331 missile visual at the largest silhouette he can see. The missile cuts through a wall of debris and detonates against another mothership just as it begins its attack run. The explosion hurls nearby FPVs off course like toys in a gale. The sky churns like a furnace. 4 motherships disintegrate under cannon fire or collide with debris clouds spawned by their own defenses. 16 FPVs vanish in streaks of flame or scatter into uncontrolled spins. Russian operators shout overlapping commands. They believe they are winning. They think attrition will end this assault, the same way it ended the first 2 waves. They fix their eyes upward, mesmerized by the strobing fire in the sky. At 800 feet, amid the blaze of tracer fire, 6 surviving Labuti strikers cut their engines to idle and die. The move is precise, violent, and invisible under the light show above. They plummet out of the engagement zone like stones, dropping into the pitch-black valley below. At 30 feet, their flight controllers scream for correction. Elevators snap upward. Engines roar back to full thrust. Nitro boost subroutines activate, pushing the motors beyond typical tolerance. The drones level out at 20 feet, lower than the lowest depression angle of every nearby turret. A Panzer operator catches a flicker of movement at the edge of his thermal camera. A blur flashes across the snowfield at 300 kilometers per hour. He jerks the joystick downward, dragging his cannons to intercept, but the turret slams into its depression limit. The barrels can angle only to -5 degrees. The attacking drones race at -10 degrees relative to his position. He can see them perfectly. He cannot shoot. The 6 strikers rip past the helpless battery at waist height, engines howling. Impact is 3 seconds away, then 2, then 1. The first Labuti striker hits the northernmost transformer dead center. Its 28-kilogram shaped charge warhead detonates, creating a lance of molten copper moving faster than 23,000 feet per second. It pierces the steel casing as if it were paper, slicing through the internal windings and exposing tens of thousands of liters of superheated dielectric oil to open air. The result is a boiling, liquid expanding vapor explosion. Under ideal conditions, these transformers could shoulder the load temporarily, but the second striker is already lining up. Just as Beta's cooling fans spool up to absorb the sudden surge, the second drone slams into the transformer casing. The explosion tears through control cabling and ruptures the oil containment. 2/3 of the station's capacity collapses in under 10 seconds. Now the grid is screaming. Voltage spikes race down transmission lines toward the Kremlin. Automated systems in distant substations face an impossible equation. 500 megawatts of demand, with near zero remaining supply. As breakers trip, power plants across the region slam into emergency shutdown to avoid catastrophic mechanical stress. The third striker's luck breaks. A stray 30mm shell from a frantic Panzer clips its tail, sending it spiraling into a concrete wall where it bursts in a muted flash. But that loss does not matter. The remaining 3 Labuti strikers close on Unit Gamma in a tight formation, flying like predators. They strike within milliseconds of each other. 3 shaped charges detonate together, and the explosion is so powerful that it fractures windows in the control building 300 feet away. The last transformer disintegrates under the combined blast. Inside the master control rooms, a field of indicator lights turns blood red. Frequency collapses from 50 Hz to 47, then 45, then 42. Turbines and power plants miles away feel the imbalance and trip offline. As oscillations ripple across the system, across Moscow, lights flicker once, flicker twice, then vanish. The MKAD ring road falls dark, each street lamp extinguishing in a chain reaction that sprints outward at the speed of electricity. 33,000 apartments lose heat. Electric boilers exhale one last warm breath and remain silent. Back in the valley, the echo of cannon fire fades, replaced by the crackling roar of a fear visible from miles away. The Russian air defense commander steps from his battered vehicle. He looks at the burning wreckage of the drones. He looks at his empty launch rails. He looks at the column of flame rising from the destroyed transformers. For 10 minutes, Russia has thrown its best interceptors, its fastest missiles, and its most responsive gun systems at a force that cost less than a suburban home. Yet the only thing those victories accomplished was clearing the path for the 6 drones that mattered. Now the consequences unfold across a city that never expected to lose its technological heartbeat in a single hour. The Kremlin's command network, stretched across a fragile chain of substations and switching hubs, depends on perfect balance. Power must glide through the system like blood through arteries. When 3 transformers vanish in a synchronized blast, that balance collapses. Emergency generators struggle to activate across strategic sites, their engines coughing to life as chilled diesel thickens in the winter air. Inside Russia's central dispatch center, engineers watch their screens in disbelief. Frequency curves plunge. Load shedding cascades uncontrollably. Operators attempt to reroute through bypass lines, but those lines trip as soon as the redirected surge hits them. Maps turn from blue to blinking amber, then crimson. They realize the fate of the grid is already sealed. Once frequency drops below a certain threshold, the network will collapse to protect itself. They can only slow the fall, not reverse it. Meanwhile, in districts across Moscow, elevator cars freeze between floors. Traffic lights die, leaving intersections in quiet paralysis. The sounds of the city dwindle. Heating pumps fall silent. Near Shatura, smoke coils upward from the molten wreckage of the transformers. Their steel frames glow orange, hot enough to warp. Fire crews attempt to approach, but the residual heat pushes them back. Jets of burning oil erupt unpredictably as ruptured reservoirs vent pressure. The flames roar like a furnace, consuming everything around them. Foam cannons struggle to make a dent against temperatures that melt aluminum. The crew chiefs know that nothing can be saved. This is not a fire to extinguish, but a wound to contain. The air defense commander stares at the devastation, stunned. His crews stand beside their vehicles, faces lit in red by warning indicators and the reflection of distant flames. A Panzer gunner wipes soot from his visor, replaying the last minutes in his mind. He remembers the blur skimming the snow line. He remembers his cannons hitting their depression limit. He remembers the helpless realization that the real attack was happening exactly where they could not reach. In the command vehicle, a shaken operator rechecks radar logs. He sees the decoy wave, the intercepts, the second swarm, the chaotic FPVs, and finally the disappearance of the 6 strikers into the blind zone. The data paints a cruel truth. Every defensive victory nudged the defenders deeper into the trap. Every missile launch emptied magazines needed seconds later. Every target they eliminated made the survivors' path clearer. The timing was engineered with surgical precision. He scrolls through the logs again, searching for what they missed, but the answer is the same. They fought the wrong threat at the wrong altitude for the wrong duration. Moscow's blackout deepens. Substations shut down sequentially as protective relays isolate failing circuits. Electric trains grind to a halt on their tracks. Traffic cameras blink off. Security systems in government buildings fall silent. Backup generators thrum inside elite residences, but their fuel reserves are measured in hours, not days. Power-hungry command centers struggle to maintain stable voltage on emergency array. The entire capital feels the cold edge of vulnerability. In the Shatura control room, a lone operator records the final status. All 3 transformers are destroyed. The switchyard is non-functional. Replacement parts will require more than a year to manufacture. Logistics chains are already strained by sanctions and war. Specialized materials, copper windings, and high-capacity cores are not items that can be ordered off-shelf. They require precision fabrication, months of alignment and testing, and continuous industry operation. Conditions Russia no longer enjoy. The shattered transformers represent not just lost power, but lost time. And time is the one resource Moscow cannot replenish quickly. Back at the valley's edge, the surviving fragments of the Ukrainian drones lie smoldering. Bent propellers, cracked carbon fiber, and twisted electronics scatter across the snow. They are cheap machines built from commercial parts and 3D-printed components. Their engines would not impress a hobbyist, and their airframes are fragile enough to splinter from a single wrong turn. Yet they accomplished what billions of rubles in Russian air defenses could not prevent. They broke the backbone of the Kremlin's command grid in less than 5 minutes of terminal flight. In Kiev, operators in the underground bunker monitor the heat bloom from Shatura through satellite relays. They watch as the northern Russian grid fractures. They watch as the blackout spreads and stabilizes in patterns matching their simulations. They do not cheer. They do not speak. They simply confirm that the operation's final phase is complete. Now comes number 1. You all have been waiting for this moment. A $700 million Russian warship versus cheap precision drones. What happened next shocked Moscow. Let's watch. September 15th, 2023 at 0530 local time. A Russian Bayan-M missile corvette in the Sea of Azov adjusted course to begin its firing sequence. 8 caliber cruise missiles sat armed inside their vertical tubes, each one destined for Ukrainian cities if the ship completed its checklist. For nearly 1 hour, the patrol had been quiet, the morning air still, the crew unaware that Shoans would not survive the next few minutes. Unknown to them, Ukrainian operators had already released a hunting pack of precision drones. 7 airframes, each designed for speed, low-altitude flight, and the ability to slip through the fractured electromagnetic landscape that hung over the coast before sunrise. The lead drone pushed to more than 400 kilometers per hour as it converged on the first Russian checkpoint guarding the coastline. The operator watched muzzle flashes erupt without warning. Tracers rose through the dim light, each glowing arc a reminder that one wrong maneuver meant instant destruction. The checkpoint gunner could not see the drone. He could only hear the thin metallic whine of its electric motor echoing between concrete walls. He fired at sound alone, adjusting his aim with every rising pitch. The drone slid left in a tight jink as 23mm shells cracked the air around it. Each detonation threw shards of steel across the path it had occupied only fractions of a second earlier. The drone accelerated again, climbing past 430 kilometers per hour, cutting through the engagement zone before the gunner could swing the barrel back. But the escape came with a cost. The eruption of gunfire carried through the valley, reaching Russian posts long before formal radio messages did. Within minutes, alerts spread across private messaging channels that Russian soldiers relied on, far more than their assigned communication systems. The element of surprise dissolved into scattered digital warnings as the drone continued its run. The operator's feed flashed with static. The camera shook. Power lines emerged from darkness only when they filled the entire image. The drone's altimeter dropped sharply as the operator hauled the airframe upward, missing 110,000-volt cables by barely 2 meters. Every onboard system glitched. The compass spun. The image stuttered. For 3 seconds, it flew nearly blind. When the feed steadied, a radio tower filled the left side of the screen. The operator rolled the drone away from the guy wires, clearing them by what felt like a single breath. 2 more drones followed the lead, spaced roughly half a minute apart, using the distraction to pass unnoticed. These were specialized variants, lighter, tuned for electronic attack. Their job was not to strike the ship, but to blind it long enough for the heavier warheads behind them to land decisive blows. 4 slower drones, carrying 250-kilogram charges each, took a northern approach, trading speed for destructive power. These were the precision hammers meant to finish the mission if the vanguard survived. But those scattered warnings had consequences. At the next checkpoint, a jammer waited. Its operator activated a repellent-class system that broadcast several hundred watts of electromagnetic interference across known control bands. The lead heavy drone lost signal instantly. The operator's monitor went black, but the airframe did not fall. It shifted automatically into autonomous mode, using stored waypoints, accelerometer readings, and optical landmarks to navigate through the invisible storm. After 3 long minutes, the video returned. The drone had held its course perfectly. A BTR-82 armored vehicle blocked the highway ahead, its machine gun already cycling in a sweeping pattern learned from earlier encounters. The operator dipped the drone into an industrial district, using narrow alleys and sheet metal roofs as shields. But those same structures sheltered Russian soldiers jolted awake by the motor's echo. They spilled out in clusters, firing at scattered noise and fleeting shadows. The drone held just 10 meters altitude, low enough that distant radar systems lost sight of it due to curvature and ground clutter. What radar could not see, rifles tried to compensate for. Eventually, a coordinated volley connected. The third reconnaissance drone spiraled down into a parking lot, its warhead detonating on impact. 2 of the lighter drones and 2 heavy airframes remained. The margin for error grew thinner with each kilometer. When the lead scout crested the final ridge, the operator froze for half a second. The briefing had missed a key detail. A Panzer ME launcher waited directly in the drone's path, already turning, already tracking. 6 missiles erupted in staggered sequence. These were newer anti-drone interceptors, built specifically after earlier failures against small quadcopters. Each missile carried a fragmentation sleeve designed to throw hundreds of tungsten spheres outward at nearly 2,000 meters per second, creating expanding rings of lethal metal. The operator knew the missiles had a mandatory arming delay, more than 1 second after launch. At the drone's current speed, it would cross over 140 meters in that time. The moment he saw ignition flares, he dove nearly straight toward the launcher. The missiles streaked overhead unarmed, passing close enough that the drone's camera flared white from their exhaust. By the time they armed, the drone sat below their lethal envelope, gliding beneath them like a needle slipping under a closing fist. The operator leveled the drone at roughly 5 meters altitude, angling directly toward the podlet radar, feeding tracking data to every system within 200 kilometers. Automatic cannons on the launcher fired in rigid patterns, attempting to build predictive boxes of fire. But their solution lagged by more than 3 seconds, while the drone changed direction. The drone slammed into the radar's antenna assembly, its shaped charge collapsing a copper cone into a hypersonic jet that punched through the array, the processing core, and out the rear wall before dispersing. The second scout dove for an older early warning radar. Dawn's temperature inversion distorted thermal signatures, turning the drone into a faint cold speck that vanished whenever it crossed cooler ground. The gunner occurred in spiraling patterns, exhausting thousands of rounds without a hit. When the shaped charge detonated against the radar housing, more than 200 kilometers of early warning coverage blinked out. The Dnipro corvette, 4 kilometers offshore, was suddenly isolated, forced to rely on its own systems with dramatically shorter detection range. The heavy drones advanced. The ship's radar struggled to separate low-flying drones from waves rising 2 meters high. Ghost contacts appeared and vanished with each sweep. Algorithms meant to filter sea clutter removed real targets instead. The corvette brought its close-in weapons online, twin 30mm cannons cycling thousands of rounds per minute. Their targeting system tried to predict the drone's paths through Kalman filtering, but the random course changes fed bad data into every calculation. Predictions collapsed into noise. The ship launched chaff next, filling the air with metallic clouds that would confuse radar-guided missiles. But the Ukrainian drones did not rely on radar. Operators watched through their onboard cameras, ignoring the floating debris as it glittered in the rising sun. The Dnipro activated its TK-95E electronic countermeasure suite, sending out 200 watts across the spectrum, from 20 MHz to 40 GHz. Against conventional drones, the signal would have severed control instantly, but the Ukrainian drones hopped between 128 channels per second in a pseudo-random sequence known only to their operators. The operator adapted, gliding over the rising waves as the sun broke through thin clouds. The captain ordered evasive S-turns at full speed. The vessel, 949 tons, required roughly 15 seconds to pivot 30 degrees. The drone, meanwhile, reacted in milliseconds. The operator timed the approach to exploit steady segments between the turns. At 500 meters, manual control took over. The radar mast filled the screen, 6 meters of concentrated electronics. The cannons could not depress below -5 degrees. Trigonometry dictated the strike. At 3 meters altitude, the drone was effectively invisible to automated defenses. Crewmen manned PKM machine guns, whirring instinctively, but each round moved too slowly. The drone crossed their field of view in 0.8 of a second. By the time the first bullet left the barrel, the drone was 100 meters away. The lead-heavy drone struck precisely at the mast, its shaped charge primed for maximum effect. Inside the electronics hub, circuits vaporized, sensors melted, communications went silent. The captain shouted for emergency missile launch, but the launch sequence required 2 minutes for gyroscopes, validation, and warm-up. Those minutes did not exist. 2 additional heavy drones closed the port and starboard sides. The second targeted the missile magazine, angled at 30 degrees to hit the junction of reinforced bulkheads. The operator compensated for the ship's drift, its 3-degree list from hard maneuvering, and the estimated motion of the 8 armed calibers. The copper cone inside the shaped charge focused explosive force into a hypersonic jet traveling 7,000 meters per second. Steel plating resisted briefly, then yielded as if it were papers. The corvette remained afloat, its superstructure blackened, its hallways charred, smoke rising intermittently from hidden compartments. The operators of the drones, hundreds of kilometers away, had neutralized a $500 million warship, using components sourced from commercial suppliers. The ship's radar now detected only intermittent ghost contacts at distances below 4 kilometers. Waves 2 meters high returned radar signals indistinguishable from drones flying at 3 meters. Doppler filtering failed. The control computer, designed to predict linear trajectories, struggled with erratic course changes between 80 and 120 knots. Every third sweep eliminated the drones entirely, judging them to be false returns. Yet the operators ignored the algorithms, relying on visual confirmation through the onboard camera systems. Twin AK-630 duet cannons spun up, firing 10,000 rounds per minute. Chaff clouds bloomed across radar screens, hundreds of false echoes stretching 50 kilometers from the corvette. Operators guided their airframes visually, slipping between false returns and electromagnetic interference. Even as the corvette's close-in weapons continued firing, the drones approached their final targets, exploiting gaps created by rapid environmental changes and unpredictable vessel motion. One drone ascended slightly to line up the Podlet K-1 radar, the system supplying targeting data for the network of Russian launchers across the region. The shaped charge struck precisely, collapsing the array into molten metal streams. Within moments, the radar feed ceased. Redundant backup systems did not activate. The drone remained nearly invisible, a faint cold speck against the sea's warming surface. The second drone angled toward the P-18's spoon rest radar. It faced automatic thermal imaging. The operator timed the approach to coincide with the peak of the inversion, ensuring the aircraft blended into the background. Gunner fire escalated, but the drone shifted unpredictably. Each pivot evaded high-speed rounds. After detonation, more than 200 kilometers of early warning coverage vanished. The Boyan M, now isolated from its support radars, relied entirely on onboard sensors with a maximum effective range of roughly 40 kilometers. The remaining heavy drones entered the corvette's immediate proximity. Ghost contacts flared and vanished with every radar sweep. The crew attempted to track targets manually, but the speed and erratic motion of the drones made human reaction insufficient. The corvette captain attempted maximum evasive maneuvers, zigzagging at 8 knots per turn, but each course correction took seconds. The drones required mere milliseconds to adjust. By the time the first missile could intercept, the drone had passed below its minimum engagement angle. The lead heavy drone executed its final approach at 3 meters altitude. The operator adjusted for hull pitch, list, and wave interference. A last-moment course correction ensured the shaped charge struck the radar hub at a perfect 90-degree angle. Explosive energy focused, metal yielded, electronics melted. Communication, targeting, and control arrays failed simultaneously. The corvette, previously a threat capable of launching 8 cruise missiles, now lacked functioning radar, data links, and early warning capacity. In less than 10 minutes, the airframes neutralized the vessel's offensive and defensive capabilities entirely. The remaining 2 drones now advanced through the chaos of smoke and debris. Waves reflected sunlight in intermittent flashes, disguising their approach. The corvette's crew, overwhelmed by multiple simultaneous failures, struggled to identify real targets. Every automated system was offline or feeding false data. The drones adjusted to account for shifting hull angles and wind gusts. Sensors meant to detect metal signatures became unreliable, as the operators had optimized flight paths to mimic natural reflections off the water's surface. One drone angled directly at the port-side missile cells, its electric motors producing barely a 10-degree rise above ambient heat. The thermal imaging system attempted to compensate for a low morning sun and a thin layer of fog rising from the Sea of Azov, but the drone remained a near-perfect cold spot. Operators on the bridge fired personal weapons and small automatic systems, but every round struck nothing. The operator timed the strike for the exact moment when thermal inversion provided optimal concealment. Smoke filled the bridge as systems failed, alarms ceased, and the ship became an island of isolated crew struggling to comprehend the extent of the destruction. The Buyanim's radar, its heart for tracking and early warning, remained blind. Waves, normally insignificant, now merged with the low-flying drones to create an almost invisible battlefield. Every radar sweep produced confusing echoes, multiple ghost targets, and false returns. Mechanical turrets fired continuously, but the drones altered course before the fire control computer could even predict the next position. Human reaction compounded the inefficiency. Eyes could not follow, reflexes failed, and the operators remained reliant on systems now made ineffective by months of Ukrainian testing and adaptation. The port-side missile cells, the very instruments meant to launch 8 calibers, became inert. 100% of the offensive capability of the vessel was neutralized without a single missile leaving its tubes. Drones maintained positions nearby to ensure no human intervention could restore partial functionality before all systems were permanently damaged. Each maneuver accounted for the corvette's exact heading, tilt, and environmental conditions. Calculated risks paid off in real time, delivering absolute precision strikes on key systems while avoiding unnecessary losses. As the smoke cleared and the morning fog lifted, the Buyan M drifted, unable to process threats or respond. Its hull intact, yet effectively blind, deaf, and mute to the surrounding environment. Crews scrambled, but every remaining system failed to provide actionable data. Early warning, targeting, communications, radar, missile guidance, all neutralized. The corvette could no longer pose a threat to Ukrainian territory or forces. The 8-caliber missiles, each a $100 million weapon, remained in their cells, unlaunched, inert, and useless. Operators monitored the scene for the final phase. One drone circled above, ensuring no backup systems could be restored. When the final assessments were completed, the drones disengaged. They returned to pre-planned recovery points, some landing safely on nearby coastal zones, others entering autonomous return trajectories. The mission, meticulously planned and executed, left no room for chance. The Buyan M, valued at $500 million, had been neutralized using commercially sourced components and careful observation. Every tactical advantage leveraged by Ukrainian operators ensured maximum impact with minimal risk. Within hours, intelligence analysts confirmed the strategic implications. The loss of the corvette's radar and control systems meant Russian operations along the Sea of Azov would be delayed. A single, precisely executed drone operation had rewritten the operational calculus, leaving the Buyan M blind, silent, and unable to threaten the coastline it once dominated. The drones, unassuming in size yet monumental in impact, had changed the outcome before human eyes on the ship could react. In the span of one engagement, precision, environmental mastery, and innovative thinking had achieved what conventional power projection could not. The mission concluded. The threat neutralized. The message unmistakable. Even the most advanced warship could be defeated by a combination of intelligence, observation, and unmanned ingenuity.